recording. We have Eugene, Richard, Liam, Maddie, Juhi, and I think Dr. Shin is here. Welcome. Welcome, Maddie. First. So Dr. Shin, are you able to introduce yourself? I think you're muted.
Can you hear me now?
I hear you.
Hello?
You're on your way to work.
Can you hear me? So actually I'm driving, so excuse me. So and very nice meeting you, Hyunjun Shin. And I'm friend of the Dr. Professor Che, and I'm very excited to work with you together. Yeah. I'm also epidemiologist, and if I can help, if I can help you, if I can be of any help to you. Yeah. So
Sure.
and this it. Sorry.
It's okay. I think you're breaking up a little bit. I think because because driving. So
Right.
no, do you want to maybe get to your office and then we can talk about our project? Because I don't want you to, drive and talk too much. So, so yeah, I don't know what your time schedule is, but we'll hopefully talk about the project once you get to your office. Is that okay? Or
Sounds great. Sounds great. Yeah, sounds great to me.
okay, good. Okay. So Richard, maybe we can start with you on your projects.
Yeah, for sure. I don't have too many updates. I've been working on, so I collected the surgical pathology IDs from the 24 patients. Actually, the thing is only 7 of them had resection of the primary tumor done here at Northwestern. The rest of them were from like different places around the US or like a long time ago, like before 2010, and they don't have like I couldn't find like a path number for them. So I just wanted to update you on that. There's only about 7 that actually have like an ID and that have like a tumor sample available here at Northwestern. Yeah, just letting you know about that. Oh yeah, and for everyone, this is about like the clinical trial. We're testing nivolumab, ipilimumab with adenoid cystic carcinoma and salivary gland cancers. So yeah, that's the update on the tumor IDs or pathology IDs. In addition, I went and collected like the primary tumor location for the patients. I'm waiting for the stats report on like the rest of like the demographics table and the IR RECIST, PFS, OS. So once I get that, I can like make a table that includes a primary tumor site as well. So yeah, I'm waiting for that like kind of like update package from the stats team to like update the manuscript and show you, because there's like a lot of data that we're still kind of waiting on from there. And then thirdly, I emailed a few journals to like let them know about the abstract. I emailed Clinical Cancer Research Cancer, which is a journal from the ACS. and shoot, what was the third one? Sorry, I'm blanking on it for some reason. Oh, GITC. So I emailed the three of them. Clinical Cancer Research got back, and they had a question that I wasn't exactly sure how to answer. The question was, so they said, like, they're asking about what is the basis for declaring nivolumab and ipilimumab active
Mm,
in the ACC and non-ACC patients.
mm,
Because they said that like the clinical course of ACC, adenoid cystic carcinoma, it tends to be very variable. And so they wanted to know, like, how can we, like, I guess, like, tell that it's actually like working just because of how variable the clinical course of that cancer can be.
uh-huh. Do you have the waterfall plot? Can you show it?
I never received a waterfall plot from stats team.
So you should request that. That's basic. So whatever you saw in the DART paper, the waterfall plot and the swimmer's plot,
Yeah,
you should, have them in your paper.
okay.
So the answer is without the waterfall plot, you cannot make any claim that it is active.
Mhm.
For cancers like adenoid cystic, if you give therapy and for the first time cancer, the size decreased, it's a proof that it's active. If it was just slow growing or wasn't growing for a while, if it's just a stable disease, we don't know whether it's the natural history of the cancer or the drug worked. The answer is we don't know if it's active. Let's say if you draw a waterfall plot and nothing goes below, meaning there was not a single patient and had decrease in tumor, then you cannot say the drug is active. You can only describe that the drug had PFS of so and so and stable disease for so and so. You don't say the drug is active, is not active. Just don't mention it. Let the reader figure it out. So you don't write anything in the abstract or in the full manuscript about its activity because it may not be active, and we don't want to be actively saying it's not active. You know what
Yeah.
I mean? Long stable disease.
Sorry,
that-
okay, yeah, I think you're cutting out a bit.
I don't know what's going on with the internet.
I can hear you now. Your picture froze for me, but I can hear you.
Yeah.
Oh, okay. Yeah, there you go. Sorry, could you repeat the last thing you said?
So the short answer is if there was no shrinkage, we don't know whether it's active or not.
Okay. Is there a p-value that's calculated usually with the plot, or is it just like if at least one patient had shrinkage of tumor, we can say it was active?
Yeah, if at least one patient had shrinkage, and it doesn't have to be like 30%,
Mm-hmm.
because that enables you to call it PR, but it could be 10% shrinkage. It could be anything.
Okay. Okay, sounds good. I'll wait for a waterfall plot and then reply to their email with like information about that. So hopefully we can like bypass like a step or two with them.
Yeah. So yeah. Work on generating all those plots and work on the full manuscript and all that. Yeah.
Okay, cool. And then I wanted to ask, a while ago you mentioned about like submitting an abstract to ASCO about this trial. Were you still thinking about that? Or do you think that there's enough for it?
So for the TIL, if you have the TIL information, tumor infiltrating lymphocyte, you can, but So, we can still try, but I think we have tight deadline. When is the deadline, Liam?
February 14th.
February 14th for ASCO. Okay. So we're very close. 14. 3 weeks. So I think in my experience, it's hard because the pathology to retrieve slide and scan it, and then Lunit does the TIL assessment, takes more than 3 weeks usually.
Okay.
I think it's reasonable to shoot for SITC. SITC is the next immunotherapy conference.
Mm-hmm.
Yeah, but still shoot for that, and then in the full manuscript, it's much better to include that. So yeah, the patient information and the sample ID, all that, send it to me and Liam, and we'll get it. Yeah. Yeah, we'll work on getting that slide scanned for this project. So, yeah. So, Liam, when you get it from Richard, let's write email to Alex, our path partner, together, so we don't forget.
Okay.
But 7 is kind of, yeah, it's at least it's kind of small.
Yeah.
Do you think it's worth it?
7?
Yeah. I mean, like, it's good to have, but then it's also effort, like, on the pathologists and I don't know, just wondering what you thought.
That's a good thought. So I think the perfect story is if there is a good responder, and that responder had a very specific TIL distribution. Even if it's 1 or 2 cases, it would make sense. However, let's look at the waterfall plot to see if everyone shows that tumor grew or something. So if you can have responder, meaning any decrease in, if it can be 2%, okay, any decrease, number 1. Number 2, if it's same, no change in tumor size, it has that has to be greater than 6 months. So we'll call that durable stable disease. So we'll figure out how many of them belong to that category. If none of them belong to that category, then what are we correlating with? Like, you know what I mean?
Yeah.
So let's figure out that first, and then see if this is worth the effort. Yeah, good point.
Okay. I'll work on getting that waterfall plot then.
Okay.
Richard, just a question. So for this cohort, I know we only had like a couple of responders, right? PRs and CRs.
Yeah.
Do you know if any of those have pathology at Northwestern?
Yeah. So the one patient with the PR had resection done at Oregon. Oregon State. I OHSU. So it's not here.
Okay. And it was just that one patient, right?
Yeah. There are a couple more with
Stable disease.
like stable disease, but
I got an idea. So the beauty of it is we're not doing new staining with this. So you know how we ask our pathologist when we say, hey, I'm writing this case report and I want you to just send me a scanned JPG file of H&E slide so that I can put in to my case report as like patient histology.
yeah.
The same thing to whoever read that path. We can find that person's email. We can call the institution or whatever. We can find out a physician's contact
Mm-hmm.
and then say, hey, we're writing this case. and we have this result. We want you to be part of our, we want to invite you as a co-author. And we want you to contribute by scanning the patient H&E slide and send them to us by email. The identity, you know what I mean? And so,
Yeah.
so you can still get the H&E slides like a scanned picture file. And that's all we need. We don't need them to send us tissue.
Okay.
So all the responders, you can, if they're not here, tissue's not here, at least we can ask the pathologist to help us obtain the H&E slide figure.
Okay. Should I do it with all of the patients who don't have slides here at Northwestern, or only like the remarkable responses?
It makes sense to do it, at least get it from all the responders and see how feasible it is. Like if you reach out and nobody responds back, and if you can't get anything from responders, then not worth it. If you get everybody like responders,
It's just one responder, Dr. Chang.
Yeah, there's
Yeah.
one. Yeah.
okay, then and then isn't there like a durable stable disease?
Yeah, there's one. Yeah.
Stable disease state greater than 6 months.
Mm-hmm.
So at least get from those. If you get it, great, and then we can think about getting some more.
Okay.
Let's work on that. Yeah.
Okay. Sounds good.
Dr. Shin, are you going to be available? Or I know you have to work, so we don't want to keep you. Are you available for a discussion or?
Me, yes, I'm available now.
Oh, okay. Well, so I think Dr. Chuhee Park and Eugene O is here. So I know you guys were, I don't know, did you guys connect through Zoom already or not yet through email?
Yeah, we just communicated via email so far, and this was the first time we're having a meeting all together. And we
Oh.
thought it would be nice for everybody else to hear it too, since you asked.
Yeah. So yeah, I want this time this is just for general, like so for all of us in the lab, this is a project about multi-cancer early detection assay. It's all blood-based assay, and we want to know how good the test is in terms of test sensitivity, specificity, and how feasible is it, and is it ready for prime time? So those are the questions, and they all use different platforms, different omics. So I think the number one criticism is how can you lump them together, pull those things together? But we understand all that limit, but we wanted to just make sure if it's multi-cancer, if it's just blood-based, if it's general population, not specific high-risk population, if you meet that three criteria, we're going to just call that MCED assay, and we're willing to lump them together. Because if you go specific, so we're going to only do the protein, DNA, some tests do combine, it just gets murky, and where's the limit boundaries. So I think we set our own criteria, and within that criteria, we're going to pull out all the data together. We don't have access to individual data, so we're going to have to pull it by whatever is available in individual manuscripts. So that's what we did, and we faced a lot of criticism and constructive suggestions. And their one comment is you really need a good statistician, epidemiologist in this project. So we recruited Dr. Shin. So we're happy that he's here to help us. But I want to hear your, like, kind of more interactive, your general comments and what the direction should be first, and then we can talk about the technical things next as a next step. But for now, I know you're busy. If you can give us like general assessment and comments and suggestions.
So I think that your idea is great, and I think this is revolutionary. And and the better thing is that we have numbers like meta-analysis. That's number which shows the not only the idea but also the objective evidence that it works. It will work. So in the future, in 10 years, I expect that this method will be prevalent method. Everyone will use that because it's money saving and it's simple, non-invasive. Everyone will use that. Also, industry wants it. What I mean is that it's like prostate cancer screening. So prostate cancer is similar. Prostate cancer screening, if the PSA is increased, that will end up resulting in a lot of tests, like prostate exam, meeting urologist, biopsy. Of course, it will end up resulting in many false negative and discomfort to patient. But even then, it's considered a standard. So we can get it. We anticipate that it will happen to this approach as well in the future in 10 years because it's cheap. And also everyone wants to know whether they have cancer or not. And this is the best way, will be one of the best way, which is cheap and without radiation. So it will be widely used. However, how can we explain this and like patient harm? That will be the main point. Like a patient will end up getting multiple tests, like endoscopy, to find out the cancer, CAT scan, PET CT. They will end up getting multiple tests after this, if this becomes positive. And then many more patients will have, because it still can be false positive, and many tests will just end up being null. So we need to explain that in the front page. So, but we can do that. Well, that's what I think. It's like we can make an analog to prostate cancer screening, like and we can explain in the background and discussion about this our approach, and we can try to persuade that and giving them that this will be one possibility that this will be the future of screening.
Thank you for that input.
No problem.
The way we did meta-analysis, how did you see that, appealing or not appealing, or what is your thought?
The meta-analysis is very appealing. It's a great method to see the objective evidence that it will work. Actually, you can say that it's better than prostate cancer screening. It's higher sensitivity, higher specificity. So it's better than that. So why don't we do that? But the issue is that the money, like a downstream test for every kind of cancer, that's the issue. That's what we have to explain to them.
So use PSA data as more like comparison about how this can be feasible.
Yes.
What about other markers? I know we don't use, what would you say, CA-125 in ovarian cancer is similar, but we don't use to detect it like prostate. So
so I think you're you know more than me about that, but I believe that PSA is the only one that widely accepted as the screening method, right? That's the only marker.
is you have alpha fetoprotein for liver cirrhosis.
Right, yeah.
But yeah, I think just having prostate data presented and then side by side how MCED compares with it is a good argument. What did you think about the pooling of different stuff? Because there's case cohort and there's a more prospective studies. So we try to do them separately, pulling them separately. And you saw the comments from the reviewer. What did you think about those?
So that's the very, very standard method. Whenever we do tests, whenever we do meta-analysis, there are data from like a prospective trial, data from the retrospective study, data from the randomized clinical trial. We lump them together and we show the separate analysis results, prospective, clinical trial, and retrospective. So that's widely accepted method. Why not? We can do that. There's no problem doing that.
Okay. Juhi or Eugene, do you have questions?
Maybe I can yeah, share some of my questions. And Dr. Shin, he has been such a great help for us. I'll share my screen just for
Yeah.
oh. Can you see my screen?
Yeah.
Yeah, so this is the email Dr. Shin got back to us. And he actually looked up very detailed information about how to conduct meta-analysis for diagnostic tests.
Hmm.
And he pointed out that actually I used the package called MADA for this analysis, but then this package are not recommended for Cochrane reviews of diagnostic test accuracy. So I had to reanalyze everything again. But then he also pointed out that heterogeneity, like the very conservative methods of calculating I-square statistics are not recommended for systemic reviews of test accuracy. He pointed out that too. So I learned a lot. It was quite a learning experience for me. And then he kind of gave us some article that we can refer to. So this was also on the meta-analysis of for like diagnostic tests using cfDNA, and I'm trying to reframing our tables or figure according to this, and because they didn't even show like I-square data which we showed, so I'm trying to I think I need to rearrange all the data in terms of figure and table. And he actually taught us how to conduct like meta-analysis with diagnostic tests in a right way. Actually, there's a really cool site we can refer to. So it's just for anyone who might be interested in like doing something like this. So you can actually load data here, and then it will give you like plot and all the like statistics. So I did that, and yeah, so I got bunch of anyone who's interested in performing something like this, please refer to this MetaDTA website. It's based on R code. It's actually made up on this long, R code. I'm trying to understand it, but I couldn't do it. So it's very user friendly, I would say. And then so I was able to draw and like get some statistics for all the subgroup analysis of us. But then I'm wondering, do we really need to show them all these results? So currently, this is the table that I'm thinking of. So sensitivity, specificity, and positive likelihood ratio. negative likelihood ratio and false positive rate. And so total, like, the study number will be like 10. I'm sorry, I haven't finished this table yet, but then I'm gonna show them subgroup results on the stage and then cancer type. But Dr. Che or Dr. Shin, like, do you think we have to show each ROC curve or forest plot for this result, or just table would be okay enough? So for example, like, mm, yeah, we can actually draw each ROC curve for every subgroup, like this. And actually, like, ROC curve is recommended for heterogeneity evaluation instead of I-square um, value. But I'm wondering, is it okay for me to just present the total, like, results for total study, or do I need to present all the, like, individual ROC curve for each subgroup? Or
I think you can do it for all type of cancer. If you can lump them,
mm,
you don't need to do it for individual type.
okay, yeah, I yeah, I understood. And then, so in a similar point Dr. Shin just mentioned, I think he recommended us to focus a little bit more on first positive rate,
Oh,
which we can discuss in depth. So this is something I tried as Dr. Shin recommended. He recommended for us to um, show false positive rate for each individual study original article, and then compare it with the pooled statistics. So I'm trying to do that, and maybe we can discuss about the impact that, like, these false positive rates will have on general population. And so yeah, these two tables will be the main table, I think. And I'm wondering, would false negative rate have the same impact as false positive rate, and or is it something we can just ignore? Or
I think we need to show both of them, false positive and false negative. Yeah.
okay, we need to show, yeah, okay, I will, yeah. And then there's one more interesting that I think that I wanna
yeah. So
ask about.
ROC curve, as
Uh-huh.
Dr. Shin said, you have to have it for perspective one and retrospective one, but all cancers.
Okay, I will have ROC card for each, like, study type, depending on study type, like cohort and case control.
Yeah, core case control, and you can do it for, we had 5 different platform, like a ctDNA, only,
Mm,
we had some
yeah.
categories. You can do it, yeah, do it that way too.
Mm, yeah, like single one and then multi-omic one.
Yeah,
Okay. Yeah, that yeah, that would be not a problem. And here's actually very interesting. So I'll just show how to do it. I'll just bring up the total data quickly, and I think it would be meaningful for us to have this figure maybe. So this is very interesting. So like, this 58% prevalence is calculated by our own data set. It means like 58% of patients was diagnosed with a cancer. But then I think maybe we can show the maybe we can show the impact of false positive rate by using this figure, and we can actually make this number as a like 10 million, like 100 million, or and then we can actually put the extra incidence of cancer, like general population, among general
Uh-huh.
population, and then I and then based on our sensitivity and specificity, we can actually have some kind of assumed number of patients who will have like positive test result despite they are not, without having cancer. But the problem is when I looked up the prevalence of cancer, like in general population, it was about 0.1%. And actually here, 1 is the lowest number that I can have. So it's not applicable in that way. But like I was wondering, would anyone would be interested in using this kind of figure, or not?
I like this figure, but I guess in our general population, was there like more like age group, and specific age group has different prevalence?
Right. So actually like 0.1% was calculated considering all the like age adjusted incidence. And but yeah, I'm not sure how I can use this.
Incident. Hmm.
So if you see the individual studies, do you know the individual studies inclusion
Prevalence?
criteria like age more than 40, 50,
Ah,
60? Maybe you can use similar age and you can use that age of our similar like
mm,
um
I
background
understand.
data,
Yeah,
right? You know what I mean? So,
understood. Yeah, understood. There might be, yeah, like average age of population of individual study, but what if they are like different? But maybe I can just calculate the mean, like average, and then yeah, I'll try that. Yeah.
so most of the cancer is the age-related disease. So most of the studies
Mm,
should have included only elderly population,
elderly. Yeah, that
like
makes
more than
sense.
40, 50, or yeah.
Um, yeah, I'll look it up. So yeah, I think we already calculate, summarized all the like age of the population somewhere else, like in table 1, or so I'll refer to that.
So this is also methylation, but they just did methylation, but very similar to what we're doing here, right? This
Sorry,
the
this
paper,
this paper,
yeah,
or this is actually one of the paper that we included in our meta-analysis.
right. But the way
Yeah.
they analyze it is similar to what we're
Mm,
doing.
yeah, they looked up. They looked at like different stage, sensitivity for different stage, and um, yeah.
Yeah, this is very similar. So a lot of things they've done, we're doing it as well. We're just doing meta-analysis, but the outcomes they
Mhm.
reported, we should, yeah, compare.
Yeah, and then yeah, right. And one last question that I have is Dr. Shin commented somewhere that among 10 studies that are included in our meta-analysis, 2 are using like multi-omic assays,
Hmm.
including cfDNA. Um, so I was a little bit confused that, oh, should I exclude that because the rest of 8 only used cfDNA, but then the rest of 2 they used cfDNA and then other like proteins or other markers together. So like, is this something I can pull off together?
Yes, you can put up everything. You can put everything together.
Okay.
The only thing is that you can show separate individual
Okay,
grouping.
sensitivity analysis. Okay,
Right, right.
okay. Understood. Yeah. Yeah, and then for further comments that he left, I think me and Liam and Jui and anyone else could deal with them. Hopefully within a few days or weeks.
Any,
Yeah,
Any
that's all
else?
for me. Yeah.
Shuhi, do you have any questions?
Not at this moment. We're gonna try to work on the meta part, based on based on Dr. Shin's comments, and then deal with the other comments from the reviewers and Dr. Shin. And then if we have additional questions, we'll try to reach out as much through email as possible, because I know Dr. Shin, you're super busy. So we'll try to email as much as possible, but if we think that's not feasible, then with your understanding and support, maybe schedule a separate Zoom meeting, but maybe try to like schedule it so that you don't have to come into lab meeting and just have it separately. So that we could work with your schedule instead. Cause I feel bad, you're driving and doing the meeting at the same time. Yeah.
Yeah, that's a good idea. Shuhi, why don't you work on that PSA data comparison thing while Eugene is working on the new meta package?
I would like to discuss that first.
Mhm.
Because when we started the PSA, I'm just thinking that's gonna be another subsection.
Yeah, so one of the questions / issues we have is the word limit. Like we're maxed out
And
in most
even
journals.
tables and figures, it's 5 for most of the journals we're looking at. I think it needs to be discussed a little bit further. Like, it's a good idea, but like, is it important enough to warrant a separate section on its own?
Or if it is, like, would you have any recommendations on maybe other sections we can cut out or shorten? Yeah, because we're like maxed out on word count and content here, because we're tackling such a vast broad topic here, so there were just so much to write and say, and also a lot of numbers that need to be presented. Yeah, I don't know. We were even like, we had entertained the thought of splitting the journal, like the article, into 2, but then I feel like that would weaken the logic a bit. So
If we split, how are you thinking of splitting?
one idea that I just thought of in the past briefly was just splitting the meta-analysis part from the narrative review, the systemic review. Or we're open to other suggestions if there is a feasible way. It just, the word limit has been an issue with the current version, and because Dr. Shin has provided us with such valuable and important insight, like, we want to include it, and we believe that it's going to strengthen our argument. It's just the matter of word count.
Yeah. So a lot of methods can go to supplemental methods.
Yeah, we already did that.
I guess you have to just cut down on introduction and discussion. But
then we have to expand discussion, because you remember the reviewer 2 was like, you guys are not really talking about the limitation of the paper. You have to discuss it in detail, why you think meta-analysis would work, because that's a big discussion that we're apparently not touching enough. So if we're gonna address that, that's gonna take up like 2 additional paragraphs.
Mhm.
It's just I just don't know where to cut and where to like.
Hmm. So I guess we have to discuss essentials and then cut down on less essentials. I mean, it's, we have to do that. I mean, things like we use that. So we'll go over the paper paragraph by paragraph, and I'll help you cut it down. But I feel like, yeah, limitations were, when we talk about sensitivity, false positive rate, all that, I think you want to compare with the most recent PSA screening essay data. I think you have to include, you need to include that to make it strong. So work on adding it, and we'll work on cutting off, the policy implications, the things that it's good to have it, but it's not essential to have it accepted. We'll just have to cut it down after we look at the word counts, but I think you have to work on getting at least a couple of paragraphs in. And then move some to supplemental, and in the results, we tend to just, write down the numbers that are already in the table. Maybe we'll work on, the results are shown in table 1, and then just not mention it again in the text or something like that. So we got to figure out a way to make it more succinct.
Yeah, so I think we should just like include all of the comments that
Mm.
came up. So we'll be well over the word count, and then we'll just have all of the content on the table, and then we'll go from there and see, what content we want to prioritize, which paragraphs to take out and maybe shorten.
Yeah, and that part will, you'll do it together with me.
Yeah.
But I think we just have to include essentials.
Yeah.
So yeah, work on those, and let's revise them, each week with the lab meeting as we go forward. And what's our target journal?
We're gonna have to get the manuscript ready, and then I'll email back JCO because they wanted me to email a manuscript draft. And then I'm guessing they're gonna respond pretty quick to my email. And if they want it edited, we'll do that. If they don't want it, then we will just go by the list. We'll go down the list.
Okay, I think the Annals of Oncology, did we ask them?
Internal medicine.
Okay, there's the Annals of Oncology was what Eugene showed us, that paper. Eugene, was that Annals of Oncology?
Oncology. One sec.
The ESMO journal.
Yeah, Annals of Oncology, yeah, correct.
Okay, we didn't consider that, but I'll put it down on the list.
Yeah, put it down on the list and see if they're interested. I think you can do the same thing, like send the abstract, and are you guys interested? And just have them as like JCO, Annals of Oncology, any journal that showed interest, we'll explore them in the order of the highest impact first. Okay, not easy, but we're almost there, guys.
Dr. Sits, before moving on to next, like,
Uh-huh.
could I just recheck I think you mentioned that you want to compare PSA data with our data, right?
Yeah.
But then wouldn't it be just enough to mention that PSA is known for like this, like specificity and sensitivity, and ours like were like this, and then just compare head to head, just the numbers. Do
Yeah.
you need? Okay, okay.
That's all we
So
need.
no need for collecting like PSA data and then calculate that, right?
No,
we
no,
just-
no, just get
Oh.
the right literature, 1 or 2.
Okay. Yeah, yeah.
Yeah, that's why I'm saying it's just a sentence, like a couple sentences, good enough.
Okay, I
Correct.
thought you wanted a whole meta review, and I was worried.
No.
I was like, how is this gonna work? Like, I can't think of a timeline that's reasonable. Well, I thought it was from the screening process, which is why I was freaking out.
Oh, no, you got it wrong.
Okay, got it.
So
I was
I'm
like,
sh- I'm
okay,
sure there will be a meta-analysis using PSA. So I think we can use the data from a meta-analysis.
okay, so we're not gonna, okay, I get what you mean. Okay. Yeah.
Yeah. We're almost there. That's why I'm saying and we we have Dr. Shin on our side, and yeah, you know, that, yeah.
Thank you.
Oh, are you in your clinic now, Dr. Shin?
So I'm walking there, so I'm going to leave now. So yeah, I'm going to my clinic.
Thank you for your time today.
Thank you very much, Dr. Shin.
No problem.
Thank you so much.
Bye.
So yeah, Dr. Shin, so we served in the military together, and he did his PhD in epidemiology at Harvard. But he's an oncologist like myself, but he also got trained in cardiology. So he studied a lot, double board trained. So he understands oncology, but he also has an epidemiology view. So he's in a perfect position to help us. Great. Well, while we have you on, Eugene, anything else you want to discuss?
Yeah, not for today. I'll bring up the other stuff by next week.
Yeah.
Wait, I have a
Very
question.
nice.
So we want to compare PSA, but PSA is for a single cancer.
Just prostate cancer. So it's
So
not
we're gonna,
all cancer, but so the whole point is PSA is probably the only, it's all general population, all men. Every primary care doctor orders PSA to screen for prostate cancer.
okay, yeah.
Only recommended blood test. But
Okay.
it has false positive, very high false positive, very high false negative. Not all prostate cancers secrete PSA. So we have to kind of know what's clinical practice now, and what kind of false positive, false negative we accept as a society, because it's a
Okay.
it's a lot of cost, right?
Okay.
So
We're-
we can't
okay.
aim for 100%, 0%, right? So what's accepted in society for single disease, and for multi-cancer, what can we accept, and how is it compared? That's kind of the question, yeah, we need to have.
Okay, I got it. Sounds good.
Basically, you want to say PSA is bad and MCAD is better, so we should accept it.
I get what you mean. I guess we want to use PSA as like a standard that
Yeah,
has
it's
been.
like our compare. It's like
and
our
then just compare it.
Yeah.
I get what you mean. The reviewers are gonna have a blast, but I get what you mean.
So we're not going to go to European Journal of Cancer. We're just explore higher, better impact journal first, because we're upgrading our contents.
Okay, sounds good.
Okay. Yeah, not easy, but still, so keep screening what's coming out. If there's, major publication or major meta-analysis already done, this is, yeah, we have to include it or something. So keep, keep your radar on, whatever's coming out during this time. That's why we need to publish it soon. Okay. Eugene?
I'll pass for this time. Yeah. I'll bring up more for next week.
Oh, okay. Okay. Juhi, are you done too? You don't, no other questions?
No, we're gonna work on what Dr. Shin said and do the review, what the reviewer said. Try to work around the word limit as much as we can. Send it to JCO as soon as we're done. If JCO is not interested, then go down the list. It's JAMA, Annals of Internal Medicine, JAMA Network Open, JNCI, plus medicine, that list down.
Yeah,
So we'll just keep going down the list.
yeah. And add the Annals of Oncology.
Yeah.
It,
Mhm.
it has a better impact
Okay.
in the middle or somewhere.
Okay. Sounds good.
Good. Stas, welcome back.
Hello.
Hey, do you have updates?
Yeah, so I let me just pull it up. I made the changes that you suggested a couple weeks ago. I also took a look at JCOPO's kind of original work guidelines.
Mhm.
And I'll just share the link to the manuscript. And now I'd like some feedback on kind of the content of the discussion. I'm still kind of working to format the results section and some of the figures, but I think what would be most helpful is feedback on kind of the discussion topics and yeah, so kind of first off, here are the JCOPO guidelines. Our text length right now is really close to 3,000 words.
Mhm.
I think there's still a lot we can cut, and we have more figures than we're allowed to. So we can consolidate some of those. And then they want us to make this consort diagram, which I didn't realize that's what it was called, but basically just a breakdown of the patient population.
Okay.
And then the last 2 points aren't relevant, I don't think. Or I
Hmm.
mean, the last one is, but yeah.
So, what do you want to discuss today?
So I guess the
Discussion?
first thing you, so the first, because I need to, so for JCOPO, I'll need to submit an abstract and kind of an outline. So I guess my first question to you, any feedback on the abstract?
Hmm.
I made the changes that you suggested.
Hmm. I think this is a strong word, considered good responder. Our high TMB. I would say tumors with high TMB are associated with, better response to IO therapies.
Okay.
That's better. Stratify. I would say in the abstract, in how many patients, like survival outcome in here, non-small cell lung cancer patient samples or something, Just
Okay.
here, say how many samples? Predictive value of TMB-IH is associated with histologic diagnosis. This is a little vague in that so can you elaborate on what you wanted to say here?
Well, I think the point I wanted to make is that is that kind of the direction, if that's the right word to use, in which, as opposed to longer versus shorter progression-free survival, whether how do I phrase this? Heterogeneity has a different predictive direction or predictive power, depending on whether we're talking about squamous versus adeno.
Yeah, I think this is a little vague. So intratumoral heterogeneity. And you can put ITH here, it's okay.
Okay.
Predict survival outcome. Here, it doesn't say anything about squamous versus adeno, right? The title,
Where in the title? No.
but do you think that is the main idea behind our manuscript?
It's definitely the most unique finding for sure.
So I think that should be reflected in the title because there's so many papers just
Right.
the impact survival, and there's nothing much special about it. Just saying. So I think number one, the question is, why did you just pick low TMB? We have to address that.
Right.
And then I think in the title we have to something like differential impact of ITH on survival outcome in early stage squamous cell versus non-squamous cell carcinoma in with low TMB, something like that.
So differential
Impact of ITH on survival outcome in early stage squamous versus non-squamous. With low TMB. Pick out the patients.
Okay. I like
So,
that.
many clinical papers use squamous and non-squamous because there's like large cell, there's
Right.
but I guess the TCGA data, the way they framed it, was it just adeno?
Yeah.
I think then we have to use adeno, then squamous versus adeno.
Okay.
Adenocarcinoma. Squamous versus adenocarcinoma.
Without lung cancer? Or early stage lung squamous versus adeno?
Adenocarcinoma of lung with low TMB. Yeah. I think that's better.
Okay. Yeah, I like that. It's definitely
Yeah.
highlighting the most interesting finding.
Our work has shown that. So maybe rephrase that here. That ITH had differential impact on survival outcome. Squamous versus adeno. Something like that. And the next sentence is 8-month longer progression-free survival. I would say predicts
Or should I switch to, or should I say a low ITH predicts a 8-month shorter progression-free survival? Because that's the other option. I only chose high here because I think that high has always been the focus in other papers where they say high predicts worse outcome. But here it's actually predicts a better outcome.
Hmm. I think I wouldn't put it 8 months, 12 months like this. I would put it as in the parentheses median. So this is, you looked at median best difference, right? So I would just write out high ITH in the parentheses to say longer progression-free survival. That's it. But the don't even say p-value. And this is too long. This I usually say p-value. I would just do, like less than 0.005
5 or 0.0. Oh, 0.01. Okay.
This one you can say just 0.004 and just say p is, and then I would just put like median PFS, certain number
Okay.
versus something,
So like 20 months versus 30 months or something,
Yeah.
20 versus 30 months or something like
yeah,
that.
same thing down here, worse for PFS or something. Yeah,
Okay,
that's usually how we present clinical data.
that makes sense. So just P less than 0.01 and P less than 0.04. Okay.
So just 2 digits for all the p-values in the future.
Okay.
Here, it doesn't. In the abstract, we didn't explain why we selected low TMB. I think they want to know. Did you explain that in introduction?
Right. I do talk about it here, kind of in the last paragraph. Yeah. So that talks about using them together, and then the last paragraph talks about, I mean, maybe I don't mention it. Maybe I just mentioned the early stage. Yeah. I need to add a more concrete section here where I talk about it.
Yeah, I think we have to say, I think maybe you can argue that high TMB is, well studied, but in low TMB, we do not know how ITH plays a role in terms of predicting outcome. So I think we have to address unmet need. High
Okay.
TMB, we have studied it, but in low TMB, we need to know more. You can have low TMB but still have very heterogeneous tumor, and how affect outcome. So maybe explain a little more.
Okay. That's helpful. So I added the distributions.
Adeno versus, okay.
Oh. Yeah, no, I mean, this is, adeno, squamous and adeno.
Everybody, not just in low TMB, right? This is everybody.
Correct. These are all early stage though. So.
Right, and your definition of low TMB is what?
Well, we have two. We have the clinical definition, and that's something that I tried to emphasize in the method section. We have the clinical cutoffs, which is 10. And then we have the kind of selected cutoff based on statistics.
Mm. Yeah, so you have high TMB 3.37, 1.95. So you explained how you selected them differently.
So the reason they're different for adeno and squamous is although the distributions are statistically identical, like
Mhm.
we showed, they're different enough where the algorithm I use chooses a different cutoff. And that's done based on size and kind of just statistics. What is statistically most significant and what is statistically most powerful based on sample size?
Mhm.
And so ITH is done the same way.
But is this? So this is everyone, figure 3.
Correct.
And then when we did low TMB, then you can see more, even higher separation.
Yeah.
Hmm. So in adeno, low TMB, but if you have high ITH, they do worse. And it's
Yeah.
all squamous. Which is kind of showing all comers and then low TMB both.
Yeah.
I guess this finding is, I guess, intensified in low TMB.
Right.
But there's all statistically significant, so. I guess which begs us a question that, that in all comers, not just low TMB as in the title,
Yeah.
you can still argue that ITH has differential impact and that those impacts were all statistically significant.
Right. So I could, yeah.
Now I'm wondering that whether we need to have low TMB in the title.
I mean, I like that idea. We start with a general approach and we say that ITH has this broad impact regardless of TMB. But then when we narrow it down to low TMB, it has the biggest impact.
Yeah. So I'm in favor of taking that out from the title because people are gonna think like, why just low TMB?
Right.
You show a figure in all comer high and low TMB, it's still statistically significant.
Yeah.
I mean, this is
TMB,
yeah.
which
But
is also kind of unusual too, that
yeah,
it switches for TMB and for ITH.
right. So I guess figure 3 is our main theme, but 4 is, it's even more pronounced in low TMB.
Right.
I guess people will ask then, what happens in high TMB? Maybe you should generate.
I did. I added a supplemental figure.
Is it this one?
Yeah, the figure 2.
Okay, so the opposite relationship still persists.
For squamous, there's nothing it's not statistically significant, but for some reason, adeno, there is some statistical significance. But what's interesting is it's more powerful in the overall survival than in the progression free, which could just be treatment dependent.
So we could say in, I don't know, the inverse relationship is true regardless.
Right.
In squamous, it just weakens, but there's some trend.
Because
uh,
the way that, and I'll probably need to emphasize this a little bit more, the way that these cutoffs were chosen, they were chosen based on the low TMB group. So you give this stats algorithm the the group you want stratified along with your biomarker, your overall survival or progression-free survival and biomarker, and then it picks that. So if we wanted to have a cutoff that works for high TMB, I would need to use that group. Which I
okay.
can't, but the point is, I mean, it'll add another figure, but the point is that it's interesting that these cutoffs still work.
Yeah. So for this figure, you use 10.
Correct.
For the other one, you showed, the cutoff generated by the program.
Yeah.
And then you have this one,
Which is both.
which is, this is 10 for squamous, but 1.95 for adeno.
Yeah. So when I used 10 for adeno, it didn't yield any statistically significant difference.
I see. So again, I think I gave you that comment. We just have to be consistent.
Yeah. It's just tough because there's only so many figures we can have, and showing figures for both sets of cutoffs, if one isn't statistically significant, is kind of cuts into our figure count.
Hmm.
So I'm not sure how to best illustrate it. I was thinking of just saying that these were the ones that were significant and then roll with that, but reviewers might wonder what did it look like. Or maybe not, maybe saying that it's not statistically significant. That's why we're focusing on these is enough. I don't know.
So you said we're over the figure limit?
Yeah, so according to JCOPO, it's 6 total figures, and that includes tables. But we can make larger figures with multiple figure pieces.
Yeah, I think we can do that.
That's one option. I don't know how many figure pieces, what the maximum number is, but
So TMB itself is not the point. So figure 2 can go to supplemental. Because our point is ITH,
right.
not TMB. So figure 2 can go to, and then figure 3 and 4 can be all combined. Because it's still high, low ITH, and it's just different groups.
Yeah.
So figure 3 can combine 3 and 4.
Okay.
And I still think the reviewers won't like, one is clinical cutoff, one is not. So I would argue you need consistent cutoff. So but I understand that it's good. So this one, figure 4 AB,
Yeah.
to do that for not clinical, but the program cutoff that you got, use that again. And put that in supplemental, and same thing, use 10 for CD, cutoff of 10.
So put the other ones in the supplemental. So say we
Yeah.
also did these, but they didn't yield any statistically significant findings.
Right. So yeah, the point is that we have to actually show it.
Right.
Okay.
And then for the drivers, I added p-value and then mutation frequency. And mutation frequency being of the samples that were processed, how many of them had mutations in this driver gene.
Hmm. So same thing, these numbers are too long, so just.
Right. Yeah,
Yeah.
I just copied them, but I can shorten them.
Yeah.
So what's kind of interesting here is that for adeno, the drivers make up a much larger percentage of samples versus squamous, which
Mm.
doesn't really have a specific driver, except for maybe this NFEL, NFE2L2,
Mm.
which seems to be present in both high and low and makes up kind of the biggest chunk of driver genes.
Mm.
So, yeah.
Okay.
I need to be a little clearer here which cutoffs I'm using, but well, I guess maybe not. Maybe I can make that clear earlier, but
Okay. We talked about in supplemental. Okay, I'm okay with the supplemental figures and tables.
I just don't know. It's unclear to me from the guidelines for JCOPO if when they say total figures and tables, if that includes supplemental.
They don't.
Oh, they don't. Okay. It's good to know. Yeah, there's one section I didn't write other than the conclusion, and that's about LUNET and EMT scores.
Mm.
The other thing I found challenging is discussing results in the conclusion without repeating the results section. So that's something I struggled with when I was writing this.
So
For now, I can just focus on getting the figures ironed out, the results ironed out, and then focus on the discussion.
so hmm. So here's the thing. I think so results is whatever we analyze.
Right.
So the numbers don't need to be explained in discussion. Discussion is philosophical. It's directions and assessment. Methodology, you know, why do I think a lot of discussion doesn't mean you discuss everything about the article. It's more about, so same thing. Number one, the first paragraph is in summary, what did we prove for the first time? Or what is the main impact of our article and its implications?
Okay.
That's the first paragraph. And the second paragraph should be, what did the literature say about this topic? Did anybody say adenosquamous is different in terms of heterogeneity? So talk about the literature and then talk, is it anything similar or contrary to what we've reported? And how is it similar? How is it different? Talk about, and you know, talk about that. And then we talk about, you know, future, what's the future of, is this the best way to assess ITH? Is there another way to do it? You can talk about ITH itself, how best it can be discussed. And our strength of this paper is that it has to be considered in the context of TMB. They're measuring two separate things. So it's almost good to think of that as 2x2 table, and
Yeah,
write our review paper before about that concept.
also histology specific
Right,
and
right,
histology and a histologic context as well.
right. So talk about any of the papers that discuss. So it's about interaction with what did the medical society report so far, and what is unique about our paper. It's always constant conversation about that.
Okay,
And
what
then
about, yeah, go ahead,
the
sorry.
future direction. That's kind of the format. So you don't have to,
Ex-
explain results again, explain the methods again, talk about the cutoff again. A lot of it is method, a lot of it is result. I feel like it's all mixed up here.
Yeah,
You don't have to say the results of, and then if you talk about other studies, always cite it. I guess you cited here.
yeah,
These two studies.
two well-studied genes.
Okay. Well, I guess if you say study, then
Yeah, I can include. So for example, like this section where I'm talking about some of this would be kept in the discussion because I'm talking about what other work has said about these genes and what they mean, but not necessarily that, for example, NFE and PIK3CA, that they're both predicted for both groups because they already know that. Or kind of, how do I explain our findings, or where do I explain our findings? That I think is what I'm struggling most with.
So the reason we're interested in driver mutation is, if you have more, well, I guess. So number of predictive driver genes did not differ between high and low ITH early stage squamous cell group. What about adeno? Did you comment on adeno? All the predictive driver genes have no significant and strong association with survival. High ITH group with shorter survival has one predictive driver, while low ITH group had 3. Yeah, it's hard to say because numbers are small.
Yeah,
There's no clear, I guess the notion, the prevailing notion is that if you have adeno and you have more driver, then you're going to likely have low ITH and maybe low TMB. And EGFR is an example. And do they drive the differential outcome in prognosis? That's kind of the question we're asking.
yeah.
Squamous, we really don't know. So I guess the question is, I don't think you did that analysis, but having driver versus no, is that how we can explain the relationship between ITH and TMB?
Yeah,
And more like sensitivity analysis. If you take out one or two common driver genes from the population and do the same analysis, do you not see this interesting association anymore.
Right, last meeting you mentioned to do that with EGFR. I hadn't done it yet, mainly
Yeah.
because, you know, when I look at to see what the mutation frequency is, it's like, let me see, let me get the exact number.
Yeah.
It's 60% of them. So if I remove 60% of them, then I'm left with like 7 samples, at least in that group.
I see.
So it kind of kills the power, but I could do that in the other group where I have a larger sample size.
Yeah. Well, I suggest you do it both regardless, just see what has happened and
Yeah,
do it in the EGFR and do it in the non-EGFR and compare. Yeah. Let's just see what happens. And we can say, well, in adeno, you know, actually EGFR was the driving force behind this relationship or things like that. Yeah, and the prior literature could be if you have these drivers, is there any literature that talked about heterogeneity with these driver mutations? If there's none, then it's, you know, we looked at it for the first time, so you argue that.
yeah.
And I think we talked about immune enrichment. But was there a difference in adenosquamous when you read the manuscript literature?
Yeah, there were a few specifically regarding like, I didn't include this in the results and I need to. I use this estimate scoring algorithm, which just looks at enrichment of stromal and immune signatures. And there was in the literature a difference between adeno and squamous. Let's see what else. Also the prognostic value of certain enriched immune subtypes was different in lung and different between squamous and adeno. So there were differences.
So here, low ITH. So I would rephrase it that higher, you know, the lower the heterogeneity, higher the enrichment for immune and stromal cells, or
Yeah.
Because you're comparing low to high ITH here, so
Right.
it's clear. So you know, things like, you know, to look at that, you use the estimate, and that has to be all in method.
Yeah.
And this enrichment, using that, should be all in supplemental figures.
So like these charts, these plots that I have,
Yeah.
and that should be in supplemental.
Yeah,
Okay.
yeah, and then the Lunit. Yeah, Lunit and all these things, when it's done, it has to be in the methods too. And because of the count limit, you can do that in supplemental methods too.
Okay. Yeah, that's what I was worried about. I didn't know. I thought supplemental figures were included in the figure count. So this makes it a little bit better.
Okay, still, you know,
Yeah,
little
it's
do, but keep working.
yeah. Thank you for the feedback. It's just been tough to kind of bring it all together.
Oh yeah. Not
And
easy,
tell like a
but
cohesive story.
as we write, it becomes more clear.
Yeah. And then the other, on a separate note, the other question I had for you was regarding Oncocyte. A couple weeks ago, Liam reached out to me about RNA-seq data coming off of Tempus's bucket
Yeah.
and trying to put it in like one place that's not the Tempus bucket. Problem is that those files are really large. So moving that for a lot of patients is just logistically challenging. So if there's a format, if there's a list of patients that of interest and a format for input for Oncocyte, I could prepare that. And that shouldn't be super large. So
Yeah, so I think the question, the research question with Oncocyte is, for patients who we have RNA-seq, just using that RNA-seq at baseline, and they receive all immunotherapy. It could be any immunotherapy containing regimen, all non-small cell lung cancer,
Right.
and we predict the outcome. So same thing, response, PFS. OS.
Yeah.
So Liam, we should work on providing that list of patient who has lung cancer, because I do, there's adenoid cystic carcinoma.
Right.
There has to be non-small cell lung cancer, has to be receiving immunotherapy as a frontline, not EGFR. So we select those patients, and a lot of those patients are in radiomics, pathomics. We've been doing the clinical annotation. They're garden patients. Haesung did a lot of work on that too. So we have that that immunotherapy patients, and we have to figure out who has the Tempus report, and that patient list is the one that we need for the OncoSite project. And for that, yeah, we'll just have to get the Tempus accession number for those patients, and then have that available for OncoSite. Maybe it's a good idea to ask OncoSite for their cloud so that we can kind of move them to their cloud with the identified data set. We just have to name the files
Yeah.
with the identified codes.
So Tempus is all via accession number, so technically it's de-identified already.
Okay.
They do have a key that you can download, but those are separate in separate locations. So
Okay, so I think the easiest is just accession number and
the format. So like what the other question to answer is, what format does OncoSite, what the input needs to look like for their algorithm or whatever they do.
but any raw, like the RNA-seq data file, I think they should be able to work with any form.
Oh, okay. Yeah, I mean, the raw files are just very large, so there's ways to make them a little smaller. So that's kind of what I
see.
wanted to simplify. But if they don't have a storage, if they don't have any storage, data storage constraints, and if we can somehow connect the two buckets, then that makes sense to me. Then we don't need to make the data any smaller. But if there are constraints, then that's what we'll have to do.
I think easiest way for us is give them our access temporarily, and then have them find those accession number for files, and have them move to their cloud and analyze it there.
Okay.
So I mean, so we can't, we don't, that way we don't have to download ourselves.
So we need to, so I guess the next thing is to come up with a list of accession numbers or a list of patients, and then the respective numbers.
Mm-hmm. So Liam, any ideas of I think radiomics, we have those numbers of patients who have, we're recording PFS and OS anyway. And I think I wanted Jisang to be involved in this as well, but because it sort of overlaps a lot with so I think this was part of the RedCap project with Samantha, that we get Guardant, Tempus, all that immunotherapy data in one place. So I guess Liam, you're ultimately in charge of the data set in our lab. So work with Liam and work with Haesung to get the accession number. So that OncoSite has access to it. And definitely Liam and Chisang and Haesung can be involved in cleaning out this clinical data.
Hmm.
It'll all be part of the OncoSite project.
So Stas, we already have the Tempest accession numbers, right?
Right. We just need to, there's just a lot of them. So if we could narrow the list of patients to the ones we're interested in, that would make things a little easier, I think, from when we're talking with OncoSite, because we'll be able to tell them, yeah.
Among all the Tempest accession data, who has non-small cell lung cancer, who has received immunotherapy. So that's the thing you need to work on.
It's definitely easier to answer which ones have non-small cell lung cancer because it's conveniently already in the key that they provided us with the accession number and kind of the patient specific information. And you can sort that, which is really convenient. But in order to know who received immunotherapy and when, we would have to do chart review.
And is there any place where that's linked to our medical record number? Or
Yeah, let
patient-
me just share the key that I'm talking about, and you'll see exactly what they have provided for us. Let me just pull it up.
And Dr. Cho, when we identify this list of patients, you mentioned like giving OncoSite temporary access. Can you clarify what you mean by that?
So the access that Stas has, just we can give them access to the Tempest cloud and have them download to their cloud. And then we can change the password later. So that it'll be access.
So this is the document that you can download straight from the Tempest website after logging in. So it gives you the accession number and then patient specific information, a diagnosis, the date of the report, the data was collected, the physician, and then different alterations, TMB values, etc. But it doesn't tell you who received what. So you can, what we'll feasibly have to do is sort the diagnosis list, pick the ones that we care about, then go to their accession numbers, or sorry, their MRNs, look through their chart, decide if they received immunotherapy before this date, and then go from there.
Do you know how many patients are on that list? I know it's a really big list.
So this list I pulled up January 10th, so it's longer now, but patients, let's see, off the top of my head, no, because you could,
Yeah, it's by essential numbers.
yeah, you would think that the easiest way to do it is to look at how long this list is, but each sample has multiple entries and each patient has multiple samples. Super long.
Why is
So-
there so many patient like duplicates for?
Because these aren't just your patients.
Oh, is it all NMHC?
I think so.
Dang. And I mean, patients have Tempest ordered repeatedly for monitoring, I guess.
Right.
Is there something that says blood versus tissue? Because we don't need blood.
I think this might all be tissue, but I am not certain. I mean, oh wait, never mind. Here it is. So this is something we can sort out too. So
Yeah.
test
I'll
description.
give you some rules. Write it down. No liquid biopsy. And then the easiest way to get lung is to find lung physicians and sort by because there's like a gyne, there's leukemia doctors, so many doctors. They would not be ordering lung. So
Right.
find the physician of order, so you know who they are. Nisha Mohindra, Yanis Balmer, Jyoti Patel, myself. Do you think they have Lake Forest people here, or is it NMH? So that's a good question to ask.
I have no idea.
Lake Forest, they see all solid tumors. So you go to the Lake Forest homepage and find out who sees lung cancer there and sort by their name. That way you'll get rid of, you know, about 90% of patients easily.
Yeah.
Because there's so many like myelomas, stomach cancers, and it looks like you cannot figure out where they're from. Adenocarcinoma could be from stomach.
Yeah.
It could be anywhere. So it doesn't, I noticed that a lot of it doesn't say where it's from. Can you show me other columns that says any?
No, I mean, I think your idea of sorting or eliminating non-lung physicians
Yeah.
is probably the right way to, that makes no sense to me, unless there's thoracic oncologists
Right.
who have multiple adenos. Some are from lung, some are from other, I don't know, or multiple squamous.
You can run that by me, but you know, but I'm giving you ideas how
Right.
very easy.
And then get rid of the liquid biopsies.
Have
But
patients-
yeah.
Is there name and date of birth?
Yep.
Okay, so you can sort that by that, plus we already have our radiomics and Guardant patient data. So you can sort that and match. If we already have data for those, you can match those patients. There's a way of matching through Excel file.
Yeah.
So you already have patient information. So find those patients in our already existing patient outcome immunotherapy database. There you have the data already. But for the ones that they have, but we haven't collected PFS/OS yet, then we should be working on those patients, which aren't going to be that many. And by the way, Tempus, I mean, we don't order, I order Tempus for every new patient, but other lung physicians, they don't. So it should not be too many. This is going to be a doable number for sure. But screening, yeah, I want you to work on this. So I don't know what, I think Dr. Chi-sang is busy with the current project, but be involved as much as you can. I think Haesung can be involved because it's going to be connected with Guardant project too,
Yeah.
originating project. So Haesung, why don't you work with Liam? Liam, you're still in charge of, you know, the structure of the database, but as far as how to collect it, how to divide and conquer, you both work together to get it done. And Wonjun, you're welcome to be part of the screening process. And we'll have more people join our lab next month. So, but let's work on this. Yeah.
What I can do, kind of just more of like a focused action item, what I can do in the meantime is try and cut this list down to something more manageable.
Yeah.
And then from there, we can see of those patients that are left, who has radiomics, and then
Right.
keep narrowing. So I can thin out this list in the next week or so. So
Yeah.
that's at least something that I can do.
Okay, let's do it.
And so Dr. Chen, just a question here. So the ultimate cohort of interest are patients who have all Guardant, Tempus, and Oncocyte? Is that what we're trying to narrow it down to?
So I'll have two answers. One is for Oncocyte project, the eligibility is they all need to have Tempus RNA-seq, non-small cell lung cancer, received immunotherapy as frontline.
As
That's it.
first line
First
or
line.
first line. Okay.
There are second lines, but I just want to make it very clean. So it's small, simple. So that's the only requirement for this OncoSite project. But somewhere between, because we have project with Guardant, Tempus, even there's Foundation, there's radiomics, there's VeriStrat data. So we've always been collecting lung cancer immunotherapy data, and we've always been, so we wanted to integrate everything together in RedCap. That was kind of our initial project with Samantha. And by doing that, I think we figured out it's not efficient enough. So we ended up making separate Excel files for all separate projects. Like radiomics has its separate Excel file. Dr. Iser Kim's VeriStrat has its separate Excel file, but they all looked at the same immunotherapy lung cancer patients. So there's got to be a way to combine everything because I don't want any duplicate efforts. So that's why we know there's a presence of all these different Excel files. But when it comes to actually chart reviewing, we don't want you to duplicate labor. So when you actually get the list, and if you're at the point where I need to do chart review, make sure you go to all the existing Excel files and then compare it and just extract those data from the existing patients. And then for that, Liam, you're welcome to make a one super database. So it's all about data structuring, data cleaning. We try to do that through RedCap. We figured out it's a lot of time and effort, and it's just it wasn't efficient. So so we would rather just work with password protected Excel file at this point. So that my I think the goal is, yes, we need to build that one big database. But for each project, it's also fine to make each database like each Excel file for each project, as long as you don't duplicate your effort. Just query all the other existing Excel file. That's why I need you to have access to all the files. So there's Guardant one, there's RedCap one from Samantha, there's one from radiomics, there's one from VeriStrat data from Dr. Iser Kim. So we have all these data sets. That's we were going to create one for pathomics, but there's a small number of patients. So as long as you have access to those data set and you have patient name, date of birth, and MRN linked to it, you can kind of work around the database. That the point is we don't duplicate going through the charts when it's already collected. But I guess the biggest data set we have is the radiomics now. So if you utilize that, I think it's going to be pretty easy to get to the OncoSite project.
And so-
Before you,
Oh, sorry. Yeah. And the Guardant database, you're talking about the portal we have in the hospital, right?
The Guardant portal, but so Dr. Haesung Kim has been collecting some Guardant data and then the Guardant patient outcome. Do you remember, Dr. Haesung?
Yeah, like 2 years ago.
I know. So why don't you tell Liam about what you've done? I think no one has worked on it since you left.
This was like a year and a half ago.
Right.
I pulled the Guardant patients and we were going through them and we did a lot of chart review.
Right.
Let me see if I can find it. I should have it here.
before you wrap up, can I say just one thing?
Yeah.
Yeah, hello, Dr. Says. I'm Dr. Yang. I'm currently working at Dr. Chase lab on radiology project. So one of the things, so you are going to use the radiology patient's data to your study. And one of the things that I'm currently really worried about is there are two kinds of patients in this chart. I'm gonna just share it. Yeah, so this is a problem. I've been trying to sort out the patients and I've been looking at every one of their charts. There are two kinds of patients in this chart. Apologies first for calling the patients as good samples or bad samples, but for good samples, this is Dr. Che right here, then this is his timeline. So if a patient get diagnosed with cancer, he comes to Dr. Che and continues the rest of his therapy for the rest of his timeline. And there are some bad samples also here. There are some cancer patients who just passes by Dr. Che. So while I was sorting out the Excel file and also genetic data, this has been a really problem to me because Dr. Che really puts big emphasis on genetic aspects of the cancer, EGFR, KRAS, also Guardant data, Veristat data. But these just passing by patients don't have those data much at all. And they sometimes, after leaving Dr. Che, and they come back with another, they meet another doctor outside the clinic and they come back again and they had a lung resection and they don't have a genetic data. So while I was doing it, we have a lot of good samples who did a lot of who did most of their treatment plans with Dr. Che, but there were also bad samples who didn't do many of the genetic sample testing with Dr. Che. So this is one point I wanted to just tell you. There were a lot of patients missing.
So if they got sample with us, still included, sometimes they go back to their local doctor, you know, whatever happens, if they were with us for a few months during workup, you know, we just censor them, it's okay. It's okay to
Yep.
include them in the diagnosis. We want to live, you know, if it's ideal if we don't have them, but still it's not a reason to exclude them from the so yeah, I you know, it's a problem with any other studies, but yeah, thanks for bringing it up. Good
Thank you,
point.
doctor.
Yeah, so Stas, do you have that Guardant data?
And so I guess Stas, is this Guardant data set any different from the portal access we're going to get tomorrow? Stas, you're mute.
It depends. So I got this data. So I got this list of patients from Guardant a year and a half ago, 2 years ago almost. So maybe they've changed their portal. Maybe they've added stuff.
But it should, okay, it's all coming from them directly.
Correct. So this is also not raw data. This has been kind of processed a little bit. So each line has the indication, so lung, classification by histology, the stage of diagnosis, all the dates that Guardant was performed. And then we tried to de-identify it. We just gave each patient a number. And then let's see, some patients had enough data that I could run a PyClone. So I ran PyClone. Some patients had TMB, some samples didn't. And then what they all had was a list of genes that had allele frequencies associated with them. And to kind of summarize that together to come up with some form of heterogeneity from that data, I looked at the variance between the allele frequency. So the higher the number, the higher the variance between. So there were some genes that had, let's say, 0.1% allele frequency, and then others that had 10% allele frequency. And so calculating the variance based on that. And so I looked at, for example, this first patient had 5 samples. And so the variance across all 5, for example. And then the difference between the first and the second. And then we did some chart review. So we had a symptom onset date, imaging date, diagnosis date. first treatment starting date, first treatment end date, treatment time, the treatment, and then the second treatment, the third treatment, and so on. And so we also had the date of radiographic progression, the date of clinical progression. So Haesung put a lot of work and time into this, so I wanna thank her for that.
Yes, here.
There's definitely a lot of extra data here that we may not need, but I think that if we're gonna approach this, if we're gonna say, okay, this patient had the sample before their first treatment, and these are the treatment regimens that we want to look at, we kind of have to do this. And then we have overall survival, the death date. Yeah.
Yeah.
And
So this is what I'm talking about. Haesung looked at the chart
Yeah.
to get all these data.
there's
So-
124 patients here.
Yes. So valuable data. So if we get Tempus RNA-seq and we have patients, so we have to find out who they are, name and date of birth, or so that we can kind of pair it up. So I don't want you guys to duplicate effort. I mean, it
Right.
has to be confirmed at some point, but at least initial analysis, we should be able to use what Haesung did to collect these data. So that's number one. Number two, going forward, what do we need to do with the garden? So we want to, continue to explore heterogeneity. Now this, the PyClone, all these things were done by stat people inside Garden. At that point, Garden policy was like, we're not going to give you raw data. Now I've been forcing them, my colleagues have been forcing them, like, that's not the right thing. You have to, share your data. So Garden changed their policy just recently, and they're like, we're gonna share BAM file with you. So that's the biggest change there. But then we're not going to do any analysis for you. We're just giving you the raw file. So the beauty is, since like a year ago, their panel was at 70 gene, but now they're doing like 300 genes. They don't report mutation in 300 genes, but now they're doing 300 genes to get blood TMB, which is amazing, right? So we're able to do PyClone for all those 300 genes. So I feel like it has to be, conversation between us and Garden about, but it's a raw sequencing data of 300 genes. So we have a better assessment of clonality. 70 genes, we know we knew from the beginning it's going to be a very limited approach. But we still did it because that's all we got. Remember that, this conversation? But now since then, we have 1 year worth of Garden, and Garden is pretty well ordered by our physicians in Northwestern. So we have access to those data. So now we're close to getting that, raw data. So now, Stas, your job is to kind of look at the data and how can I run PyClone? And, I was, saying Haesung and Ether can all be involved in, and running this PyClone because it's a lot of data. So the future is with the expanded panel, let's do our own heterogeneity analysis. It could be simple PyClone, but we wrote that review paper. We can kind of add some layers of our own technique and see, and then what seems to correlate best with patient outcome, right? So so that's kind of Garden project. We want to do the same thing with the Tempus tissue heterogeneity. How does that assessment, because we have access to Tempus data already, so develop blood-based, tissue-based, and just make sure our algorithm is performing well first, and then we're gonna go to what's overlapping and develop what's combined. So that's our ambitious goal. But we start from now it's just a little step towards getting access to data and coming up with our own algorithm. So I think that's the future for the Garden project. But today, I think, what you showed us, make sure Liam and Haesung has access to that and use that, patient data to make sure there's no duplicate in OncoSite data in terms of getting patient outcome data. So that was the point for today's discussion.
Right.
Yeah. But thanks for bringing it up so that we can
Yeah.
clear goal. So, it's same thing with your how does heterogeneity impact patient outcome? And it's going to impact it in chemo, immuno. So same, Jian, Dr. Jian's project is same thing. Because we're gonna sequence it, ctDNA by Predicin is going to be limited panel. It's not going to be 300 panel. So blood DNA is not good for clonality assessment, but you have tissue. So you're going to sequence the tissue with probably something like whole exome. So if we get BAM file from that, we could get the file and Stats can run PyClone and assess the tumor heterogeneity. And then does tumor heterogeneity impact the response rate of PCR of neoadjuvant chemotherapy? So that's a good question to ask. So it's all connected. How does heterogeneity, clonal heterogeneity, genetic heterogeneity impact outcome of chemo, immunotherapy, targeted therapy? But immunotherapy is the most important piece, and that has a lot of interesting preclinical data. Haesung has looked at it. So that's sort of the main theme behind everything we do. Yeah, and how does TMB interact with all that and all that? And then immune microenvironment interact with that? How does TIL interact with that? We don't know. So we are exploring that. And the endpoint is, how can we make that a clinical variable? Just like TMB, can we come up with ITH value that everyone agrees on and the best evidence with the clinical value? So I envision a future where in every report there's like nice ITH index, and I'm hoping that our group will continue to contribute in developing that concept, ITH. And that ITH has to come not only just tissue, but from blood. Because so people just talk about blood TMB, that's it, right? But we're always saying we have to talk beyond that. It's not blood TMB is not ITH, and not many groups talking about it. So we're still pioneer, and I think Foundation is awfully interested in that. Tempus is interested in that, but we just have to continue to develop it with our own data, but then hopefully we have access to the whole Guardant, whole Tempus data, and they have their outcome. So hopefully we'll generate that thousands of patient level data and prove that, ITH is really important and develop that as a marker. So that's the endpoint. Okay. Okay, Stas, anything else?
Nope, that's it.
Okay. I think we need bathroom break. Let's take a break, 10 minutes. We'll resume. Okay, we're back. Is Jisang available to give us any update? Are you available, Jisang? Maybe not now.
Maybe I should continue.
Okay,
I'll give him a call in the mid.
go to Jian. Okay, Jisang's here.
I'm here. I will give a quick update. Now let me share my screen. Yeah, here. So this is the Venn diagram I showed before. So it was about 70 patients in our abstract, and our goal is to fill the gap of the clinical data and like this. So maybe we will get another about 110 patients clinical data, and we'll get about more than 100 patients in the menu. We will update this for a manuscript. So for now, about 50% of gap was filled, and I have quick questions for Dr. Che. So, so we are, Dr. Yang and me are filling the gap, but so ALK has two type of mutation, like rearrangement and amplification. So are you gonna use both or just one?
So amplification does not matter. It's only the rearrangement.
Rearrangement, all right. And I want to ask about the time points. So it's a little bit confusing to choose and decide time points about TNM staging and every genetic mutation test and the metastasis. So is it so should the time point be initial diagnosis of lung cancer or the diagnosis at starting immunotherapy?
At diagnosis.
So initial diagnosis of lung cancer, is that right? For all three questions.
So initial diagnosis or any time before starting immunotherapy is fine.
Oh, okay. All right. So for all three questions.
Yeah. So
Is
initial
it-
diagnosis or any time before starting immunotherapy is fine for all three questions.
Oh, okay. All right. Thank you. And yeah, so some patients will be excluded because some patients had other type of cancer like a small cell lung cancer or thyroid or other metastatic cancer, and some did not receive immunotherapy. So I think it would be about 100 patients in total after we finish gathering these clinical data. All right, and I got an email from Yuri. So I will contact Edwin for the CT scan, the DICOM files. with assistance of Liam. So this is you resent about the question.
So, yeah, contact Edwin and the IRB, attach the retrospective IRB.
Mhm.
And ask which files, which date and which patient you need to have it downloaded.
Mhm. All right. So I heard from Liam the IRB can include all patients that
Mhm.
you in the hospital, right?
Yeah.
Okay, all right. I see. And from Henley, it will take a few weeks to get an access to the image trial, new beta version of the program. So after we get the DICOM files from Edwin, then I will contact Henley again.
Yeah, and then we can upload there and we can do the resist.
So we are not currently collecting the time point of CT scan and resist. So I hope the program will find resist and progression information more quickly.
Yeah, the program will do it for you, but you have to go into the image and measure it yourself.
Measure by myself.
Yeah.
Okay,
The
all
way
right.
you measure it is if you go to our Epic, it's already kind of measured by them. So you
By radiologist,
yeah,
right?
yeah, and the measurement is reported in the report.
Uh-huh.
So you would just upload the DICOM file and try to measure the largest diameter they measured. Just duplicate that effort.
Oh, okay. So I think then it'll take more time to finish to fill the gap. So, all right, I see. Then we will calculate resist by ourselves and by the program both. Is that what you mean, right?
I don't think we have to calculate resist per se. I think he was just saying we need to measure the target lesions as the radiologists did.
So two things. To do this, I don't know which will take more time. The whole point is use this program to make it much easier for you. Because what ends up happening is just by reading the report, you don't know if there's a progression or not. You can say there's a clinical progression.
Oh, so we also are gathering the clinical progression data. So it's different from the exact resist or the exact progression by resist.
Yeah, I know, but my point is, if you need to do resist progression, time to best response, resist progression, you have to have resist measurement for each scan while they're on therapy. There's no way to go around that. And to do that, just having a radiology report, isn't enough. 2 per organ, in the lymph node. You have to have target lesion set up and then just follow that target lesion each time. Measure the exact same target lesion with each scan. Sometimes that's not always available in the radiology report. And you don't know if that lymph node they measured is the same lymph node. So you have to be able to do resist for every scan. But to do that takes a lot of time to calculate and ensure they're, to put them in Excel file and do all the math. But if you actually do the measurement in the program, then you should be able to get the outcome, immediately. The program will do it for you. But you have to manually measure each target lesion in every scan. Do you understand?
So in Epic or by the program?
In image trial.
Right.
But because it's hard for you to do it, I want you to pull up the Epic image on the side and have the report out as well and see exactly what they measure. So you can measure the exact same thing. But you might have to measure more because they don't always measure everything. You have to measure other things by the RECIST criteria.
Like lymph node or metastasis.
Right. And you cannot measure more than 2 per organ. So you have to follow the RECIST rule.
Right. I see.
So doing that, I know it's a big task, but I think that's the way it should be done. But it doesn't mean you should, but I do feel like it's going to take time, but if we upload all the image, you could do that in Korea. You could just access that website. It's DICOM files going to be already uploaded.
Right. So I think I can do this after we get the image trial beta version.
Right. So before we get the beta version, we just do it as what we've been doing and finish what we have first and get the data out. But once we get the beta version, then we can do the RECIST ourselves, actual measurement RECIST.
Okay.
I think we have to do that because the reviewers will ask us to do it, anyway.
All right.
And I think in the end, it's going to save our time huge because it's going to give you spider plot, waterfall plot. It's going to give us everything we need.
Okay. All right. Yeah, I think that's all.
Did you talk to Yuri about this program?
Yeah, Yuri. Yeah, he's interested in the program, But I think I can update the information after I get the better version and after I use it. So yeah, I will explain later
Okay.
to you.
Before we wrap it up, can I say something?
Sure. Are you done,
Yeah.
Susan?
Yeah, I'm
Okay.
done.
Can I gotta share my screen. Just a minute. Okay, I prepared the meeting. Well, 1 to 3 is for nothing, just a minute. Yeah, currently project, this is a Venn diagram just Jisung showed a few minutes ago. This is total patient of 69 patients, but we are right now currently dealing with 71 patients, which means we got 2 patients missing somewhere. I'm gonna deal with that by today using calculator. And this is our progress so far. Dr. Jisung is coming top to the bottom, and I'm going up bottom to the top. So thinking about his speed and my speed, we'll be able to meet somewhere around here this Thursday. That means we're gonna able to fill all the blanks in here by this week. The process is we're currently using beacon buttons to take a look at the genetic aspect of the cancer. So like I said, Dr. Che, you put very much emphasis on genetic aspects of the cancer while other oncologists may not. So most of the genetic aspects are usually in the physician note. If it's not in there, we use the beacon button to search these things. Gardens report, Tempest report, Veristat, which is Biosex report, and Natera report. If it's not there, we search the keyword for genetic. Mostly it's done, but if it's not there, we manually search each one of these genetic markers, MSI, TMB, EGFR, KRAS. If it's not there, we write it non-applicable. So we're doing three layer search for completeness sake. Right now, this is my note. I'm going bottom to the top. So I write down every reason why I excluded this patient. So for example, this is the first patient from the bottom. This patient was actually a thyroid cancer patient who received immunotherapy, wrongly chosen patient. And for this patient, look at this. This is the third patient from the bottom. This is the reason I filled in the all exemplex. This patient got ipilimumab 4 doses, and this is biopsy. Other progressive metastatic disease found in the CT scan. So I am trying to do this as complete as possible. This is currently, just I explained to Dr. Stas, most worrying point. Your patient who's been meeting you since the diagnosis of cancer till right now has a good report of genetic data and no missing data. But sometimes patients just passes you by. These patients has almost no data, missing data. So we have to, I've been searching thoroughly, but their Excel blanks are non-applicable. I couldn't find them at all. Problem 2 is there are some reports. There is a record of you that you ordered these tests, but we didn't receive any results. So I am leaving this as a blank filled with question mark. We're going to search after with your ID and password at these homepages, Guardant and Biosynthex. And I have already explained, I already heard the explanation from Dr. Lee, and we can do this. The third problem is most of Dr. Che's patients has TNM stage written on it, but there are some patients who just passes by, only has this TNM final stage, doesn't have a specific T and M. So I am currently leaving them as blank because although I can look at the CT scan and find about the T stage and make a deduction about N M stage, but these takes too much time. But currently, right now, our goal is to fill in as many blank as possible. But is it okay if I just leave it here
Okay.
as blank? Because okay,
Is that all?
no. So yeah, these will leave it as blank and decide whether to fill it or not at the later time. So estimated time for completion is this Thursday, and me and Dr. Jisang, we're gonna double check it. We're gonna review it until this Friday. So you're gonna able to see the complete report by this week. That'll be all, sir.
Good. So don't leave blank the stage. You can figure out whether it's 1, 2, 3, 4.
Yeah,
You can do that. But you can leave TNM blank. Don't
yeah.
and people who don't have reports, you did your best to find it. You don't find it, just leave it blank, or you searched and it's not there. Maybe you want to say that you actually looked at it and it wasn't there, versus just leave it blank, because we don't know if you looked at it or not. You know, you'll know, but the people who looks at the data might not know. So make sure the blank means you looked at it and wasn't there, versus you haven't looked at it yet. You know what I mean? Just make sure you clarify that. But everything else looks okay. So yeah. So I guess first analysis was not significant. We're getting more data and to see if the URI's radiomics is any significant or not. If it's significant, good. And then we want to know what features are significant, how, but I feel like there's a good chance that it might just come back. Radiomics is not significant, not a good predictor. Then we use picture health algorithm. Finish the MTA, a DTA or data transfer agreement. Send them our radiomics DICOM image file to them. Let them do their own radiomics. We have our outcome already collected to see if the picture health does a better job. If picture health says no, I mean it doesn't work, we are going to say, why don't we merge with your own data set? And can this be your validation set, not just a data set of our own? So that's my plan. The third is we send to Lunit. They have their own radiomics. I think they said they're overwhelmed, but I think we should be able to work with them in a few months later when they have more workforce to work with this. And the goal is is radiomics related to pathomics? It's another story. That was our initial plan, but we'll get as many H&E slides as possible from these patients and see if there's any correlation between pathomic and radiomics. Okay, any questions?
No, thank you, doctor.
No problem. Okay, Sion, do you have update?
Yes, I will share my screen. The first is about the original article. It is almost done, and I want to make sure I review this articles. So title was decided at last meeting, and it is original article. The target journal is the Journal of Heart and Lung Transplantation. And original article should be less than 30,000 words, but it is almost 2,600, so it could be all right. And do you want to submit this to ASCO conference? do I need to ask to Professor Ankit as well?
Yeah, before you submit, just
Mhm.
final review, yeah.
Okay, do you want to submit this as an abstract? Do you want?
Oh, where? ASCO?
ESCO, uh-huh.
Oh, we haven't submitted this to anywhere? What did we submit to AACR?
AACR was just about the case report, which is related to cardiopulmonary bypass was associated with a better recurrence-free survival.
But what data was that from?
Only case series.
Oh,
Pooled analysis.
Oh,
Yeah,
it was only case series, so I didn't catch that.
yeah.
Oh
and
yeah,
it-
this is new data and this is lung cancer outcome.
Yes, actually, at that time, we were prepared the brief communication, but now it became original article and we have more data, more outcomes.
Right.
We changed the original article.
Yeah, I think ASCO is still good.
This is the abstract. I need to make sure confirm about especially conclusion.
And this one, we have 3 data set case series. Precise protocol. I don't like the wording. Let's change it. I guess this data, the OPTN, ISHLT, they're prospectively collected data, right?
Yes.
It's gonna be hard to say we need larger perspective data because that's the best we have, right?
Always I use that term, I'm sorry.
Okay. Reasonable survival outcome can be achieved with. Okay, I think we can be just vague. Further studies are needed. However, just further studies are in this special special indication for bilateral lung transplant BLT. Further studies. Yeah, just leave it very vague. Further studies are needed.
Okay. At least we have to mention about the post-transplant lung cancer, even in conclusion.
Studies investigating post-transplant lung cancer. Investigating the incidents or investigating the Risk. Investigating the risk of who's I would take out, however, just say further studies. Yeah. Yeah, I think that's better.
Can you check keywords?
Yeah,
Post-transplant lung cancer, should I put into this keyword?
post-transplant lung cancer. Yeah, make it post-transplant lung cancer.
This one?
Yeah,
Then how about, what about the bilateral lung cancer? Could it be,
lung cancer is good too.
okay, then I will put both. Mm.
Can I ask one question?
Uh-huh.
So in the results, what does that mean that CSS in 3 cohorts were better, were all better than OS?
That is the cancer-specific survivor. The patient died because of the cancer.
So in this case, the patients died of causes other than cancer.
Oh, I see. Thank you.
And you have to decide which one do I really need use.
Just going back to that.
Okay.
Any CSS will be better than OS in any study because OS is always worse. They die of car accident, something else.
Mm-hmm.
So I'm thinking
Better put out.
you don't have to describe it that way. I think cancer-specific survival was, I would say, median cancer-specific survival was in the range so for 3 cohorts respectively or
Oh,
so.
okay. All right.
Yeah.
Okay.
And I would just separate those 2 sentences, not
Mm-hmm, mm-hmm.
different ideas.
Yep. Yeah, sure. I'm gonna revise it.
Okay. Okay. Anything? Oh yeah, you were gonna show me the graph.
Oh, yes. I made a couple of graphs about the cumulative risk. Now this is a recurrence about the risk. Here is the n. Y-axis shows n number, and the below graph shows the percentage. Which one do you prefer to use in this graph? Or another one is with the cumulative risk, a cumulative percentage.
Yeah, so definitely like the one together
Mm-hmm.
rather than each one, but I think that's the best graph.
Okay.
Yeah, that's the best graph. But this one is not raw number, so I think you can put
Mhm.
the very first one in the supplemental.
Oh, this one?
Yeah, that one, because that's a raw data.
Uh-huh.
Yeah, you can put that supplemental.
All
in
right.
The third one.
Mhm. And this group should be a main figure, one of the main figures.
Yeah.
All right. Okay. Actually, that is all I have today. And the next stage is after completing this manuscript, then this week, I will get the English editing by Liam, or I will use other company. And then I will send it to you for review.
Good, thank you.
Thank you, Dr. Chen.
Hansong, do you have update?
Oh, yeah, I'm trying to share my screen. Oh, yeah, so this past week, I worked on the Tempest chat proposal. Would you like to see that first? So this is the tab proposal I wrote. I can also send you the link. Would you like me to do that?
Oh, no, it's okay. You can just scroll it as,
Yeah, so I just wrote your name and then I just wrote the four of us. I mean, is there any changes that you would like to make?
oh, no.
Okay. And then for like tumor type, like the relevant patient population, stuff like that, I just wrote 499 patients with squamous cell carcinoma, receiving people who have received immunotherapy at any line of treatment. And then we're gonna ask for the TTMB data, the tissue TMB data.
So
And
let's
then we're gonna predict
immunotherapy or immunotherapy mono or combo at first line. Let's just make it very clean.
okay, so mono or combo at first line. And then our goal is to predict response to immunotherapy in patients with squamous cell carcinoma. And the modality, I think you also said include the transcriptome, so DNA, RNA.
Yeah.
And then tumor tissue, and then yeah, for this one, the assay. Which one are you doing?
So we say targeted panel or WES. I don't think they'll have whole genome. That's too much.
Mm.
So
The
targeted
or
whole exome. Either one is fine for DNA. RNA, it's whole transcriptome.
yeah. Then here, the clinical data required. This section is referring to this part, like what results are we gonna look for, and what I think outcomes the one that we want. So that's what I put. I just wanted to confirm.
Yeah, this is everything, right?
Mhm.
So pretty much everything relevant to lab data. I don't know if they have lab data. I don't know if they collect that though, but I don't think they have it, so I worry. But it's always good to have an lymphocyte neutrophil ratio. So absolute neutrophil, absolute lymphocyte number, and its ratio. We can ask if they have it.
The outcomes plus the lymphocyte neutrophil ratio, right?
Uh-huh.
Okay. And then,
Yeah.
yeah, for the complete.
Sometimes because they do tissue sequencing, they make H&E.
Yeah.
So we can ask if they have picture files of H&E slides.
Okay.
And other specific
Mhm.
estimated a year. Let's put 1 year.
And then, would you like to review my background?
For heterogeneity. That's okay.
Yeah. Okay.
I guess that's background. Yeah. Then okay.
Yeah, that's just background. And then, yeah, for this one, you did say don't mention blood in the composite. I just thought, I don't know, just to give them a full picture, I just wrote it.
Well, I guess here the ctDNA is from blood, and we're asking for tissue.
True. Yeah, I don't know. I just wanted to give a big picture, but is that not necessary?
So I guess for the 499 patients tissue analysis, let's not mention anything about blood. It's future direction, not something we're gonna do it here. Let's take out
So
everything.
should I just get rid of the highlighted part?
Right, you can still cite our paper. But you can use all the terminologies used for tissue only.
I should still mention the PyClone stuff though. So
Yeah.
I guess we'll just, okay, yeah, I'll just somehow
So
just focus on tissue. And,
you have to write the hypothesis. The hypothesis is that
oh, sure.
tumor heterogeneity index would be predictive of, I guess, worse outcome in patients receiving immunotherapy in non-small cell lung cancer.
Yeah.
And that's hypothesis. We don't know if that's true or not, so we want to prove it.
Yeah. Forgot the most important part. Yeah. Yeah, this is. Can you still see? Is it still small?
A little bit larger. It's okay.
Like that? Is it okay?
So clinical unmet need, we have TMB, BTMB, those are all, those are, those that have limits.
Yeah.
So we need a measurement. Yeah, this is okay.
Yeah, and then I cited the UVB paper here that forms the basis of our, our study.
I like it.
Cool. And then here, I'll zoom in more. Yeah, this one was tricky, but
How may clinicians change their management of patients based on their results?
oh, sorry.
So you use less intensive monotherapy, low dose therapy. That's fine. I think, yeah, you can leave it as is.
Okay. And then, so at this stage, we're just ideation, and then it says like, what's the IP status of the algorithm? I just said it's published. We're basing it off of the JCO or JICO
Yeah.
paper.
Yeah.
JITC, yeah.
Yeah.
Okay. I'm not sure though. Can I let in?
Blood. Hmm. Okay, so we can leave that as secondary aim. Now,
okay.
what I don't know is for these people who have tissue sequenced, I don't know if they have blood sequenced as well. And I know they have a lot of tissue, but their liquid biopsy has not been done for a long time. Okay, now I'm changing direction a little bit. So if we leave the secondary aim, and we're gonna still use blood,
Yeah.
we're gonna say, they probably have squamous cell lung cancer patients, about several thousands, because the company has been around for a long time now.
Yeah.
Now, among those whole, like non-small cell lung cancer squamous, I believe some will have liquid biopsy as well.
Yeah.
Because my lab is ordering both at the same time. Some labs likes to, they like to look at the liquid as well. So you can ask them to prioritize the patients who actually have tissue and blood. Blood, I mean at the start of therapy or before therapy. Can't be during therapy. So if they have both samples, give us both sequencing data for both tissue and blood. That way, in the aim, you can just briefly talk about composite or integrated heterogeneity index that we want to develop. You don't have to go through like the whole table 2, things like that, but just briefly mention as a secondary objective, we want to analyze both blood and tissue and blood together if we have enough blood samples.
Okay.
But
so
is that there is not going to be many patients that will have both. I just worry that they're gonna be like 20 patients or but we can request both, prioritize ones that have both to be sent, max of 499.
And we'll be just asking for these separate requests on the email, right? Not on this paper.
No, in this paper.
Oh, in this paper, okay. And so do you mean we're gonna run the analysis on Tempest blood and tissue as well as Garden blood? Is that your point?
Mhm. But
Okay.
again, the blood we're not going to touch. We're gonna finish the tissue first,
Yeah. Mhm.
but it's good to get the Tempest blood data, in one queue.
Mm. Okay. And the ones that finalize this, should I just send it directly to the team, or would you like to check once again before submitting?
No, you can have Liam take a look at it before you just proofread it and then send it. CC me to
Okay.
the first team. Yeah, it's fine.
I also wrote the introductions for the 3 DART trials. Would you like to read that?
Yes.
It's for the ovarian stuff, and then yeah. This is for the small cell carcinoma of the ovary. And this is what I wrote. Can you see enough?
Mhm.
That is the main one.
So I like it, but what's missing is
Mhm.
lack. So I guess as always, explain the concept, explain why issue is important, to explain the knowledge and explain what's actually happening and explain what's the gap. So you're explaining, this hypercalcemic type is important. It's rare, but it's like, we don't know much about it. This is what we know so far. And the reality is there's no therapy that works really well for these patients yet. We don't know. So
Mhm.
that's the reality. So how do you feel in the gap? So we need to see how combination immunotherapy works. The gap is
Mhm.
the EVO-EP trial for this this type of cancer has never been designed or reported. Is that true? It was the monotherapy.
Yes, it's true.
Yeah. So we have to say that, no one looked at it. And this is the first time we've looked at it in the prospective clinical trial setting in this rare tumor.
Yeah, I
So
did write. It's the first result.
yeah. So explain more about the gap. But I like the direction and everything you've written. So good.
Okay, I'll try to clarify the gap. I'll move on to the clear cell gynecologic cancers. Sorry, I'll try to put this in one place.
Mhm.
Is that too small?
No, it's fine. I can still read it. Yeah, this is because you're dealing with 3 different type of cancer. You have to, right?
Yeah, so I squeezed it in, and then on the last paragraph, I just said, the double combination therapy hasn't been tried.
Right. MMRD, I would say I don't know if you wrote MMR up front, but mismatch, I would just write it out for the first time.
Oh, sure, yeah.
So here you CCCC, you said last sentence has not been proposed. So I would say not proposed, but that it has not been investigated as potential treatment.
Okay.
Because anybody can propose and not do it, you know what I mean?
Yep. Okay.
So let me ask you, was there an article that showed Clear is likely to be a good candidate for immunotherapy, or has there been any trial showed
For clear cell, right?
Clear Cell that PD-L1 worked really well?
There was this trial for clear cell endometrial carcinoma. Let me see. Yeah, so it's not a combination therapy, but they did try the addition of immunotherapy, and I
But
really summarized it here, but yeah.
endometrial cancer as a whole, they did a trial, and so pembrolizumab was approved for any endometrial cancer. It's FDA approved regimen.
Oh,
However, I don't know if there is a data showing that subgroup clear cell is a good candidate or a bad candidate, or like what is the subgroup analysis in their pivotal paper? Or
okay, I'll look for that.
any paper just looking at clear cell versus a more common type of endometrial. So that's
So this one, cabozantinib, only looked at clear cell endometrial cancer. Should I try to expand on this study? I think they did show some response, but I thought it was different from ours.
so I think here you leave it vague, but I guess pembrolizumab, the study that I know was not clear cell directed. It was more like all comer.
Oh, this one. Oh, right. Oh, sorry. Okay, yeah, I'll clear that.
So, but I don't know if they have a subgroup data in their paper that says clear cell worked as well, then you can still cite it here. But if there's no subgroup data, then, you know, may not worth mentioning because our topic is clear cell, not just endometrial.
Yeah.
And for everyone here, something is associated, significant, important. You leave it very vague that some concepts are important in this aspect, which was better, but don't go into actual numbers or details. How many patients were enrolled and how many responded. Those are too heavy for introduction. Bring all of this data, like Nivo Carbo data. It deserves like a paragraph in discussion. Here you just mention it that, you know, people are considering this concept, but still this is monotherapy plus TKI, not immunocombo. So no one still has looked at, you know what I mean? So the point is, these are all rare. There's not much out there about the immunotherapy being a potential good therapy option, and no one actually looked at immunocombo. So we're the first to report. That's the whole point, but yeah, I think it's fine to leave it like this.
Should I move on to the next?
I'm just wondering. I think it's okay. You're saying CCCC, it's unique disease model and just that does, we don't know much about its origin. We just know DES that. Okay, okay, pretty good. So I think method and outcome is pretty straightforward. You can rephrase. It's DART study. It's gonna be same for all the studies. Outcome is pretty calm. You just fill in the blank for the numbers. Discussion will be just extension of a lot of the introduction material you wrote. So like we told you did we show that it was working or not working? It's working in this subgroup. First to show that it's working. And then what did the literature show so far? There's nothing in the literature or and then you talk about future directions. Where are we heading? Do we need a separate trial to look this up in a more larger patients? And do we need a biomarker? So yes, we just say we have planned to explore all these DNA, RNA, protein like biomarkers. And those languages are all written in our DART manuscripts. We plan to do this and that. And because it's a rare group, this should be proposed as a potential future option for patients. And in fact, some of our DART papers are cited and got into like NCCN guidelines.
Yeah.
So if you write this up, people will cite this paper, and in the ovarian cancer NCCN guideline, they can cite this paper and then put Nivo-IPI. And then everybody, all the oncologists will look at that guideline and use it. So that's how we change therapy. Okay. So I think the response rate was pretty good. So okay, good.
There's one more for the non-epithelial ovarian tumors. This one, interestingly, there's an ongoing clinical trial with durvalumab and tremelimumab, but it's ongoing. So versus like ours is already studied and is about to be published.
Oh, and this is germ cell?
Yeah, just only in germ cells. Yeah, that's true. And ours is more comprehensive.
Oh, okay. That's why we gotta publish this sooner than that. Okay, so non-epithelial, the definition, rationale, less evidence is known, and then linked to immunotherapy. Then we're doing this therapy. Good, very standard. So I would argue that you put the durva-tremi in discussion. You don't have to say that in introduction.
Oh, okay.
So prior literature or ongoing other efforts, all discussion.
Okay.
And the result is not even, so look to see if they published or presented any oral poster anywhere, abstract. Sometimes
I couldn't find it, but I'll try.
yeah. Sometimes it's not, doesn't come up in Google. PubMed has to be abstracts. A lot of abstracts don't come up in PubMed. So let's say for you to search it up. So ASCO, ESMO, SITC, AACR are all like the big 4 meetings. Okay, so go to their website and under their prior abstract search, you can search there. And then don't forget it's germ cell. So gynecologic oncology, group, look for those gyn-onc specific meetings. I don't know, there's gonna be 1 or 2 that's very famous. So go to their meeting website and search abstract there to see if any of these are, so that's the best way to search ongoing trial preliminary reports.
Mm.
And you can, if you find any, you can discuss it. Same thing, you can put, somebody else might have had presented an abstract with other drugs as an abstract form. So
Mm.
look at it there. But good. So
Okay, and then
did you meet
I
with,
have a
did you do the Zoom meeting yesterday?
oh, so we got it moved to tomorrow.
Ah.
Yeah, sad. And then so for journal club, I have a couple things. PARP inhibitors, in lung cancer, and then Nature evidence-based medicine, and then the UVB melanoma. Which one would you like me to present?
So let's do one at a time. Got a lot. Let's do the Nature. It's short, right? You Nature.
Yeah, it's more of a okay. I mean, yeah, sure. Oh, wait, this one? Okay, everyone can see this one?
So
So yeah.
I'll just give you a background why I selected this. Vivek is a good friend of mine.
Oh.
We did a fellowship together at MD Anderson. So he went to medical school in India. He came here, did med-ped combined residency. And he came to MD Anderson and he did med-ped oncology combined fellowship.
That's crazy.
So he is boarded, and he so it's 4 years each. If you do just the med-onc and adults, it's going to be 3 year, 3 year, 6 years. That's what I did. This guy, because he added ped, 4 year, 4 years, so he made it 8 years of training. Wow. And I came to Northwestern. He stayed at MD Anderson. He's phase 1 there. So that means, same thing, rare tumor, like all tumors, early phase trials. That's all he does. And he wrote this nice perspective article in Nature Medicine. So at times, I wanted to give you this idea. Who's going to be thought leader? The thought leader in your field in breast cancer, I like Martine Piccart. What's her name? Dr. Jill. Martine, is it her name? Do you remember her? Martine Piccart?
In MD Anderson?
No, she's from, I think, Belgium.
Belgium? I'm sorry, but I never heard her name.
Oh, maybe she's medical oncologist. You don't
Oh, yeah. That's why I couldn't remember.
There's a surgeon at Dana-Farber, Bertolli, B-E-R-T or something. And you quickly find thought leaders in the field. I was just going to try to give up. Charlie Swanton in lung medical oncology, he's kind of thought leader. He developed this idea of tumor heterogeneity. So when you are pioneering field, or you have your own unique vision towards in that field, you have to write perspective papers. You have to write, this is going to be the future type of paper. But you can't do it unless you know exactly what's going on in your field. So That's why I like to write review papers and meta-analysis and perspective paper or narrative review, whatever it is, to sum up the field and have a perspective for future. And in the world of clinical trials, we need thought leader. And I think Vivek's trying to be one by writing papers like this. There's no magic, there's no magic recipe here. It's kind of writing out what's actually happening and what's going to happen more in the future. So having this insight or foresight is it's really important. It sort of separates you from being visionary and just being more like you work for someone who wants you to do some, project, and you do the thing you. So for those people, it doesn't matter where you work. As long as they pay you, you have the skill set, you're going to be satisfied. So this is one type of people, but the other is visionary. Like you have to have a meaning. You have to have a perspective, vision for future. And you can't not work for others. You have to be the one to initiate the project, carry it through. You have to have people around you to believe in your vision and carry that on. So, I hope you all be visionaries in the future. But in the field of academia, part of writing a perspective article is one of the ways to show your vision. And it's pretty obvious in the field of like one specific question, like minimally invasive surgery, like liquid biopsy. But it's hard to do that in the field, like in the clinical trial, genomic medicine, or individualized medicine. It's kind of big topic. So how do you approach that? So let's see how Vivek approached that.
Okay, let's see. So yeah, I thought it was a really good educational material for students and doctors, including myself, who aren't too familiar with the process involved in clinical trials. But we're also eager to learn about an expert opinion on his vision of future clinical trials and evidence-based medicine. So our expert, Vivek Subbiah from MD Anderson. Subbiah.
Yeah.
You said? Okay. He wrote this perspective on nature because he felt that we've made huge advances in basic science and technology, but translating the results to the bedside has been lagging in major areas of medicine. Yeah, so here he begins by showing a figure that illustrates the timeline from drug discovery to first in human phase 1 trials and ultimately FDA approval. In the second row, he explains that the attrition rate for early stage developmental therapeutics is quite high, as more than 2/3 of compounds succumb in the valley of death between bench and bedside. In the third row, he shows that by the time trials are completed and published, they can become quickly outdated. He adds that to bring a drug successfully through all phases of drug development into the clinic costs more than $1.5 to $2.5 billion. This combines with the inherent inefficiencies and deficiencies that plague the healthcare system is leading to a crisis in clinical research. Therefore, he argues that there's an urgent need to reinvigorate clinical trials through drug discovery by interpreting imaging, streamlining EHRs, and improving workflow, all of this to ultimately advance public health. And AI can aid in many of these aspects in all stages of drug development. He stresses the importance of trial design. Better protocol designs lead to better clinical trial conduct and faster go or no-go decisions. On the other hand, losses from poorly designed failed trials are not only financial, but also societal. In the last decade, the design and implementation of master protocols, meaning overarching protocols that apply to several sub-studies, has substantially improved the stagnation of RCTs. 4 different classes of studies are included under the master protocols. And here, the 4 of them are listed here. I'll just go briefly what each of these means. In basket trials, targeted therapy is evaluated on multiple disease types that all harbor the same underlying molecular aberration. Thus, these are also called tissue agnostic or histology independent studies. And one clear example is what you guys just saw earlier, is Dr. Che's DART trial, where both anti-CTLA-4 and anti-PD-1 inhibitors are given to various rare cancers and tested for efficacy. Umbrella trials are study designs that evaluate multiple targeted therapies for the same disease entity stratified by molecular alteration. Platform trial. Sorry, I wrote I wrote the notes. Can't find it, but what this is so this one is a very flexible trial where even after starting the trial, you can do subgroup analysis. So you can do multiple interim analysis of the same group. And so it really, saves time, and it really generates a lot of information from a small group amount of patients. For the MOT trial,
What is
basically in this,
MOT?
what it stands for, I'm not too sure, actually. Did not look that up. It didn't say on the paper. Do you know?
I don't know. That's why I.
One second. Yeah, sorry, I'll look that up right now. Medication? No. Yeah, it didn't say on the paper, and I just Googled it.
Medication overuse treatment.
Yeah, medication. But in this trial, basically they just recruit a bunch of patients independently of biomarker signature and collects comprehensive data on each participant. This approach could be well suited to collect prospective real-world data across many specialties.
Wait, go back.
Oh, sorry.
So master observational trial is the one that comes.
It says medication overuse treatment strategy trial, but that one, to be exact, is not. But I guess it is not trial.
Master observational trial
Oh.
hybridizes the power of molecularly based master interventional protocols with the breadth of real-world data. So I guess broad inclusion criteria. This is like a real world. I guess based on all the biomarkers, you deliver different drugs.
Yeah.
This is like the and ASCO had a trial that was called TAPUR, TAPUR. That sounds like a MOT trial. Okay.
And in order to fast track drug development, Dr. Subaya argues that we will need to, first of all, define biomarkers, whether it be clinical, pathological, or physiological, and their context for use for every disease process. Number two, delineate clear endpoints for studies. And these biomarkers can be diagnostic, prognostic, or predictive, and it can inform early drug development, dose selection, and trial design. By endpoints, we mean measures of health and/or disease, and those that serve different purposes depending on the phase of the trial. Especially digital endpoints need to be standardized and harmonized. Sorry, I'm not sure why the font is this way. This is especially relevant in interpreting the data generated from our digital devices, such as using smartphone microphones to monitor cognitive decline in people with Alzheimer's disease, or smartwatch monitors to evaluate drug effect in people with sickle cell anemia. One randomized study even showed the superiority of digital atrial fibrillation detection over usual care. NIH and FDA have also developed BEST resources, which stand for biomarkers, endpoints, and other tools to clarify the ambiguity in biomarkers and endpoints. It's this living document that is continually updated as standards and evidence change. The components of clinical trial conduct are protocol implementation, patient selection and recruitment, monitoring and retention, ensuring compliance with safety reporting, and continuing review and data analysis. The pharmaceutical industry and the healthcare sector invest substantial resources into clinical trial conduct, but changes are urgently needed to make the process more seamless. Moreover, the pace at which clinical trials are conducted is too slow to match the research advances in every field. And thus, a high-tech transformation of every component in a stepwise manner is needed. One of the positive sides of the pandemic is that it has forced the system to redirect clinical trials to be more patient-centric than before, as you can see in the middle, thus giving more importance to the principal subject of clinical research, the patient. This has led to decentralized trials and digital, remote, and virtual trials, which allow patient access to trials regardless of their geographic location, as well as hospital at home and home-based monitoring concepts. Adopting an AI-based approach can further improve high-fidelity assessments and ensure compliance with protocols. Dr. Subaya also argues that there's an urgent need for global harmonization across regulatory authorities to address the substantial inequalities in access to medicines. A few examples of these regulatory authorities are FDA, European medicines, etc. Ideally, clinical trials for new therapies should be conducted globally for access and generalizability. However, the reality is that clinical trials, including RCTs, can't be conducted in every country to generate specific evidence for that country's population. So what we could do is evidence generation using transportability analysis. And this refers to the ability to generalize inferences from a study sample in one country to a target population in another country where the study was not conducted. New methods to generate evidence of clinical benefit may accelerate clinical trial conduct, and they may also provide individuals with rare diseases access to new therapeutic compounds. There's becoming an increasing regulatory flexibility to use programs such as accelerated approval program, and there are case scenarios by which trials have used external control arms based on real-world data. These things called N-of-1 trials are emerging as a tool to study potentially fatal rare diseases. This trial is a single patient clinical trial using this individual person as a unit of investigation to evaluate the efficacy and or adverse effects of different interventions through objective data-driven criteria. One prominent example is the development of a personalized antisense oligonucleotide therapy for a patient with a fatal genetic neurodegenerative disorder known as CLN7 neuronal ceroid lipofuscinosis. One of the major criticisms of all clinical trial research is that clinical trials do not represent the real world population. It's often due to the restrictive criteria and the limited analyses framed to answer specific questions, and they may not always apply to real world patients. Conventional trials have been designed on the basis of misconception that regulatory bodies may not accommodate more modern and diverse evidence from real world data, which is no longer the case. Regulators have taken a hands-on approach and provided guidance and a comprehensive framework launched through the 21st Century Cures Act. Nowadays, the FDA even uses real-world data and real-world evidence for post-marketing safety monitoring. And insurance agencies have started to use such data for coverage decisions. The use of these real-world data and real-world evidence has been necessitated by rapidly accelerating data inputs from multiple streams and layers into electronic health records, as well as wearables and biosensors, in parallel with new analytical capabilities, such as multimodal AI, to analyze the vast amount of data. Now, advances in the genomics of rare diseases and the discovery of rare oncogene-driven cancers have led to specific targeted therapies for which evaluation in RCTs may not be feasible or ethical and may delay patient access to promising or life-saving therapies. In such cases, synthetic control arms are emerging as options for generating comparator arms that can mimic the comparator arms of RCTs. These synthetic control arms are external to the study in question, and most are derived from real-world data. These real-world data can be obtained from EHRs, administrative claims data, natural history registries, and patient-generated data from many sources, including wearable devices. These synthetic control arms may also be generated from previous clinical data. This is an emerging area primed for innovation, as so much data are now available from multiple sources. They have also been used for drug approvals for ultra-rare diseases such as neurofibromatosis. Many rare and orphan diseases mainly occur in the pediatric population, and drug development in this population has always been operationally, ethically, statistically, and methodologically challenging. This is compounded by the limited understanding of the basic biology, the ontology of disease manifestation, and the acute and long-term safety of products. In addition, there's considerable off-label use of products in these very young children, infants, and neonates, where clinical trials have not been feasible. And it's imperative that high-level evidence be generated by creative methods. So in order to overcome these challenges, programs such as Best Pharmaceuticals for Children Act and the Pediatric Research Equity Act, made permanent in 2012 under the FDA Safety and Innovation Act, have incentivized and enhanced the development of pediatric therapeutics. In this evidence-based deep medicine iceberg, Dr. Subaya shows that the current evidence-based medicine pyramid represents only the tip of the iceberg. It barely shows shallow evidence to care for generic patients. Therefore, a deep synthesis and amalgamation of all available data is needed to achieve next generation deep evidence-based medicine. The main challenge in the next 2 decades will be to tap the potential of multidimensional evidence generation by mining large sets of natural history data, genomics, and all other omics analysis, all published clinical studies, real-world data, data from ubiquitous smart devices, and amassed data from the Internet of Medical Things to provide next-generation evidence for deep medicine. Currently, the pharma industry is the main driver of drug development. Their expenditures far exceed investments from any national agency, such as the NIH. In this area of reduced federal funding for research, more partnerships are needed for drug development. And that would include partnerships among specific disease organizations, academic institutions, federal agencies, and patient advocacy groups. And innovative partnership models with pharma industry have set a precedent in diseases such as cystic fibrosis, multiple myeloma, type 1 diabetes, and other rare diseases. Even social media outlets, such as Twitter, can influence patient accrual in clinical trials. They can strongly influence and address historical clinical trial challenges, including the lack of awareness among patients and physicians about available trials and lack of community engagement. People with terminal diseases often self-experiment with drugs and online patients communities can provide environments for sharing and monitoring such drug usage. This can allow for observational studies to be planned around quantitative internet-based outcome data. For example, researchers developed an algorithm to dissect the data reported on the Patients Like Me website by people with ALS who experimented with lithium carbonate treatments. This analysis reached the same conclusion as an ensuing RCT, suggesting that data from online patient behavior can help accelerate drug development and evaluate the effectiveness of drugs already in use. And that's the end of his
Great.
perspective on EVM.
That was a nice summary. I just want you to have an idea of the whole clinical trial industry and different perspective. But yeah, you did a great job. We have to get I think we wrap up here. I think we have a meeting with Tempest now. So
Yes.
who's gonna be on the meeting? I think
So I'll have to be there. Who else would you like?
I think Haesung and Jiyeon can listen, yeah. And this is the mucinous one, right? So maybe Jisang too. Jisang's been involved in mucinous too, so.
All right, I'll send them the link.
Okay, so we'll wrap up here and